Hello and welcome to my science tutorials. In today's video, we want to learn how to simplify algebraic expression. So let's begin by looking at this example that we have over here. So we have 2x plus 4y minus 5z minus 5x minus 9y plus 2z plus 4x minus 7y plus 8z. So this is the equation that we have, the algebraic expression, and we have to simplify this algebraic expression. So what do we do? The first thing we do is we look through the equation and then we group like terms. By like terms, it means we look at the numbers that have the same variable and we group them at one side. So if we look through this entire equation, we have three variables. We have x, y, and z. So we need to group the variables one after the other. So let's start by grouping the x all at one side. So I have 2x, which is the first s over here. I have minus 5s, I have 4s. So let me bring the 4s first. It doesn't matter how you arrange it, you're still going to get the same answer. So I brought the positive 4s first. Now I am bringing the negative 5x. Okay, so let me use another color for the second variable. So I'm done grouping the x terms. Now I can go ahead and group the y terms. So the y terms, I have 4y, negative 9y, and then negative 7y. So I can go ahead and write plus 4y minus 9y minus 7y. Then I can now go ahead and group the z terms together. So let me use another color for that as well. So for the z component, I have negative 5z, and then I have positive 2z, then I have positive 8z over here. So I can write my negative 5z first, then plus 2z plus 8z. Okay, so from here all I need to do is to simplify my equation by solving or adding or doing the subtraction when necessary. So over here I have 2x plus 4x, that is going to give me 6s, then minus 5x. Then we are done with this. If we come to the y component, we have plus 4y, then minus 9y minus 7y will give us minus 16y. Then we have minus 5z, then 2z plus 8z will give me 10z, so plus 10z. So from here I can go ahead and simplify my equation further. So I have 6x minus 5x, that will give me x. 4y minus 16y will give me negative 12y. Then I have minus 5z plus 10z will give me plus 5z. So this becomes my answer for simplifying this algebraic expression that we have at the top over here. So let's go ahead and look at another example. Right, so the next example we want to look at involves brackets. So we need to remove the bracket. So we have to simplify the expression. Simplify the expression. 3 into bracket 2x minus 4y, bracket close, minus 4 into bracket x minus 5y, bracket close. So this is our expression, and we have to simplify this expression. Now this is very easy. The first thing we need to do is to get rid of the bracket that we have. We do that by multiplying or expanding the bracket. Okay, we do that by expanding the bracket or opening the bracket. That means we use the number or the value outside the bracket to multiply everything inside the bracket. So 3 multiplied by 2x, that will give us 6x. 3 multiplied by 4y will give us minus 12y. Then we have minus negative 4 multiplied by x will give us negative 4x. Negative 4 multiplied by negative 5y will give us positive 20y. Okay, so now that we are done expanding the bracket, the next thing we need to do is to group like terms. By grouping like terms, it means that we group together all the x components of this equation, and then we group together all the y components of this equation. So if I do that, I have my 6x over here, then I bring the 4x close to it, so it becomes minus 4x. Then I write plus 20y. Okay, for easy arithmetic, I decided to write the 20y first. Then I will now write the negative 12y, so it becomes minus 12y. So from here, it is pretty easy and straightforward for you to just go ahead and solve. So you have 6x minus 4x, that will give us 2x. Then plus you have 20y minus 12y, that will give us 8y. So this becomes our answer. Or you can still do it as this is equal to, if you look at 2 and 8, they have a common factor. That common factor is 2. So you can factor out 2, then you write into bracket x plus 4y. This is the same as this, because if you expand this bracket, this is what you get. So you either leave your answer as this or you leave it as this. Either way, you still get your answer to be correct. Alright, so let's simplify another expression. So we have x into bracket x plus 2 minus into bracket x minus 4. Okay, so this is our next expression we have to simplify. So this is equal to, as usual, we expand the bracket first. So we use the x to multiply the content in the bracket. So x multiplied by x will give us x squared, plus x multiplied by 2 will give us 2x. Then we have negative 1. This is negative, so it's negative 1. Negative multiplied by x will give us negative x. And negative multiplied by negative 4 will give us positive 4 over here. So now all we need to do is to go ahead and simplify the equation that we have. So we have x squared here, so we maintain the x squared. Then we have plus 2x minus x will give us x, then plus 4. Now if you look through what we have over here, we have x squared term, x and 4. They don't have the same variable, so there's nothing we can do any further. So this becomes our answer for this particular expression. Okay, so let's go ahead and simplify the following expression. So we have to simplify the following. So we have we have 8x plus 3x plus 4x minus 6y plus 12y. That is our first expression. Our second expression is 3p plus 3 plus 5p minus 7 minus 7p minus 9. And then our last expression is 2k plus 3m plus 8n minus 3k minus 6m minus 5n plus 2k minus m plus n. So you can go ahead and try these expressions yourself, try to simplify them, and then once I'm also done, we can compare our answers. So take the next few 4, 3, 5 minutes to simplify the following expression. Alright, so let's start with the first expression. So we have 8x plus 3x plus 4x minus 6y plus 12y. Now this is pretty straightforward, very easy. This is equal to, already the terms have been grouped for us, so there's no need we do any grouping. All we need to do is to add the terms. So we have 8x plus 3x, that will give us 11x, plus 4x, that will give us 15x. Then we have minus 6y plus 12y, that will give us plus 6y. So this becomes our answer. So our first answer is 15x plus 6y. Alright, so let's tackle the second question. We have 3p plus 3 plus 5p minus 7 minus 7p minus 9. Okay, so to solve this, we can see that the terms have not been grouped, so we need to first of all group these terms. So for us to do that, we group the p terms at one side, so we have 3p plus 5p over here, then minus 7p over here. Then we group the terms that do not have any variable, that is just the numbers. So we have plus 3 minus 7 minus 9. Okay, so we can go ahead and now simplify our equation. So we have 3p plus 5p, that's going to give us 8p, then minus 7p, then we have plus 3 minus 7 minus 9, that will give us minus 16. So we have 8p minus 7p, that will give us p. Then we have 3 minus 16 will give us negative 13. So our answer for the second expression is p minus 13. Alright, so let's go ahead and solve the last expression. So let me quickly erase here to get some space. Okay, so for the last expression, we have 2k we have 2k plus 3m plus 8n minus 3k minus 6m minus 5n plus 2k minus m plus n. Right, so the first thing we need to do over here, as usual, we need to group like terms. So we write 2k, then the next k content we have is 3k over here, so it's minus 3k. Then the next one is 2k, so we have plus 2k. Then we go to the next term, which is 3m, so we have plus 3m. Then we have minus 6m, and then we have minus m over here. Then we move to n, so we have plus 8n minus 5n plus n. Now you have to be very careful when you are grouping like terms so that you don't forget one of the variables or one of the numbers that you have in the equation. So always count to see if what you've rearranged is the same as what you have at the top. So we have 1 2 3 4 5 6 7 8 9. So I have here 1 2 3 4 5 6 7 8 9. Also, you need to make sure you check the sign so that you might not accidentally taken, let's say, negative 3k from somewhere and you've written plus 3k when you are rearranging, because that will give you a wrong answer. So always make sure you check the number of terms and then the signs as well. It's very, very important. Okay, so from here we can go ahead and simplify. We have 2k minus 3k, that will give us negative k, plus 2k, that will give us positive k. Then plus we have 3m minus 6m minus m will give us 7m. Then we have plus 8n plus n will give us 9n, so 9n minus 5n. Okay, so we have k here. Then we have 3m minus 7m will give us negative 4m. Then we have 9n minus 5n will give us plus 4n. Okay, so our answer for the last expression is k minus 4m plus 4n. So thank you so much for watching. In the next video, we'll be learning how to factorize algebraic expressions. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to factorize algebraic expressions. So without further delay, let's begin. So let's look at the first example that we have. We are to factorize the expression 12x minus 18y. So this is the expression we are to factorize. So we have 12x minus 18y. So this is equal to, now when you want to factorize, the first thing you need to do is to Look at the coefficient of the variables that we have. So we have 12 and 18. So you try to write the factors of 12 and 18, or the numbers that can easily divide 12 and 18 without a remainder. So if you take 12 and 18, the factors that can easily divide them, we have 2. 2 can easily go into 12 and 18. 3 can also do that. And then 6 can also go into 12 and 18 very easily. Now, these numbers becomes the factors of 12 and 18. Over here, we need to pick the largest factor so that it is easier for us to operate with. So we factor out 6 because 6 is common for this. So we write 6 outside, then we open a bracket. Now, 6 times what will give you 12? 2. 6 times 2 will give you 12. So you write 2 inside the bracket and you add the variable x. Then you bring the sign. Now, how many times will this 6 outside the bracket go into 18? It will go there 3 times. So you write that 3 over here and then you attach the variable y. So your final answer becomes 6 into bracket 2x minus 3y after you are done factorizing the expression given above. So what is the point over here? The answer that we have, if we expand the bracket, we are going to get a question. So 6 multiplied by 2x will give us 12x. 6 multiplied by negative 3y will give us negative 18y. So it's just an expression that brings out a factor and then some numbers with their variables inside the bracket. Alright, so let's have a look at another example. So we have to factorize the expression s squared minus 2xy plus 3xz. So this is the expression we have to factorize. Now, if you look at the expression, the coefficient of the x squared term is 1. The coefficient of xy term is negative 2. The coefficient of xz term is 3. Now, what is common among all these variables that we have? We have x here, x here, x here. So x is common for all the variables. So we factor that x out. So if you bring that x out, we open a bracket. Now, what will you multiply by this x to get this x squared? X. So x multiplied by x will give you x squared. Then you proceed minus 2y. It means if you multiply x by negative 2y, you get negative 2x at the top over here. Then you have plus. Here we have 3xz. So here becomes 3z. So if you multiply the x by 3z, we get 3xz. So this becomes our answer for factorizing the expression above. Alright, so let's go ahead and factorize the following expression. So we have to factorize the following expression. So we have I 72f minus 36g minus 48h. I 12a plus 15b minus 18c. I 12k squared plus 144km minus 72kn. Then IV p squared minus pq plus PR. Okay, so we have to factorize the following expressions. So this is very easy. Let's go ahead and look at the solution that we have. So we have 72f minus 36g minus 48h. Now, if you look at all these variables, you can see that 72f minus 36g minus 48h, there is a number that can go exactly into 72. That same number can go into 36, and that number can also go into 48. So we need to find that number. And what is that number? Now, 12 can go into 72, it can go into 36, it can also go into 48. So we factor 12 out because 12 is common for all these numbers, or the coefficient of the variables that we have over here. So we factor 12 out. So we open a bracket. What number will you multiply by 12 to get 72? That is 6. So 12 multiplied by 6 will give us 72. So we now add our f to it. Then minus 12 multiplied by what will give you 36? 3. So 12 times 3 will give us 36. So we now add the g. Then minus 12 times 4 will give us 48. So we add the h. So our final answer becomes 12 outside bracket 6f minus 3g minus 4h. So that becomes the answer for the first expression. So let's tackle the second expression. We have 12a plus 15b minus 18c. Over here is the same as the first one. There's a number that can go into 12, 15, and 18 without any remainder. And that number is 3. So we factor the 3 out, then we open bracket. 3 multiplied by 4 will give us 12. So we write 4a here. Then plus 3 multiplied by 5 will give us 15. So we write 5b here. Minus 3 multiplied by 6 will give us 18. So 6c. So this becomes our answer. 3 outside bracket into bracket 4a plus 5b minus 6c. That becomes our answer. So I. We have 12k squared plus 144 km minus 72 kn. Okay, now if we look through this particular example, we see that the coefficient of the variables that we have 12, 144, and 72, there's a number that can go into all of them exactly. And then again, there's another common factor over here. That is, we have k squared here, we have k here, we have k here. So k is common among all of them. Alright, so we also need to factor k out. So if we look through all these terms over here, we see that 12 can go into 12, 12 can go into 144, 12 can also go into 72. So we factor 12 out. Not only 12, k is also common, so we factor 12k out, 12k. Then into bracket. Here we'll be only left with k. So 12k multiplied by k will give us 12k squared. Then plus 12 multiplied by 12 will give us 144. So we have 12m over here. So 12k multiplied by 12m will give us 144km. Then minus 12 multiplied by 6 will give us 72. So we have 6n because the k has already been factored out. So this becomes our answer. 12k outside bracket, then into bracket k plus 12m minus 6n. So let's look at the last one. The last one we have here is p squared minus pq plus pr. So this is also fairly easy. We can see that p is common among all the terms that we have over here, so we need to factor p out. So we write p outside bracket, then into bracket p minus, over here we'll be left with q, then plus r. So if we use p to multiply everything here, we get all that we have at the top over here. So this is a simple example on how to factorize. But let's look at a more complex examples. So we are to simplify the following expressions, factorizing the answer where possible. So let's look at that. So the instruction is to simplify the following expression. Following expressions, factorizing the answers where possible. All right, so we have 8 into bracket 3x plus 2y plus 4 into bracket x plus 3y ii, 2 into bracket 3a minus 4b minus plus 5c minus 3 into bracket 2a minus 5b minus c. Then I, we have 4 into bracket L plus W plus H plus 3 into bracket 2L minus W minus 2H plus 5W. down. All right, so we have to simplify the expressions and then factorize the answers where possible. So let's go ahead and see how to solve this problem. Now you can go ahead and try the expressions, find your answer, factorize the answer if possible, and then we compare at the end to see if we are all correct or on the same page. So let's write down the solution. So we have I 8 into bracket 3x plus 2y, then plus 4 outside bracket x plus 3y. All right, so the first thing we need to do over here is to expand the bracket so that we can see everything standing by their own. Then we group them and then we simplify them. All right, so if we multiply 8 by 3, we are going to get 24. So we have 24x over here plus 8 multiplied by 2, that is going to give us 16y. Then plus 4 multiplied by x will give us 4x, plus 4 multiplied by 3 will give us 12y. All right, so from here we can now group like terms. So we have 24x plus 4x, then plus 16y plus 12y. All right, so 24x plus 4x will give us 28x, plus 16y plus 12y will give us 28y. Now if you look at the answer that we have over here, you can see that 28 is common for both terms, so we can factor it out. So we factor out 28, so we have 28 outside bracket, then into bracket x plus y. So 28 outside bracket x plus y becomes our final answer for the first expression. All right, so let's look at the second expression, I. So the second expression is 2 into bracket 3a minus 4b plus 5c, then minus 3 outside bracket 2a minus 5b minus c. All right, so as usual, we need to expand the bracket first. So this is equal to 2 multiplied by 3a will give us 6a, then minus 2 multiplied by 4b will give us 8b, then plus 2 multiplied by 5c will give us 10c, minus 3 multiplied by 2 will give us 6a, 3 multiplied by negative 5b will give us positive 15b, then 3 multiplied by negative c will give us positive 3c. All right, so now that we are done expanding, we need to group like terms. So we have 6a, then we have minus 6a, that is all for a, then we have minus 8b plus 15b, then plus 10c plus 3c. Okay, so I have 6a, 6a, negative 6a, negative 8b, negative 8b, 15b, 15b, 10c, 10c, positive 3c, positive 3c. Okay, it's very important to always check the signs to make sure you don't change the signs when you are rearranging or you are grouping items. All right, so 6a minus 6a, that will give us 0. Negative 8b plus 15b, that will give us 7b. Then plus 10c plus 3c, that will give us 13c. 13c. All right, so 7b plus 13c, there's no number that is a factor of 7 and at the same time a factor of 13 apart from 1. So there's no number that can exactly divide 7 and 13 exactly. So there's no factor over here, and then it means we cannot factor any further. So this is our answer for this expression. Now let's have a look at the last expression that we have over here. So I. So we have 4 into bracket L plus W plus H plus 3 outside bracket 2L minus W minus 2H plus 5W. All right, so as usual, we need to expand the bracket. So we use 4 to multiply everything in the bracket here. So we have 4L plus 4W plus 4H plus, we use 3 to multiply everything here. 3 multiplied by 2L, that will give us 6L minus 3 multiplied by w will give us 3w, minus 3 multiplied by 2h will give us 6h, then plus 5w. So we group items over here. So we have 4l plus another l over here, that is 6l, then plus 4w. The next w is minus 3w. The next one is plus 5w. Then we move on to the h. We have plus 4h, then minus 6h. Alright, so we can go ahead and simplify. We have 4 plus 6, that is 10, plus 4, that will give us 14. Sorry, 4l plus 6l, that will give us 10l, plus 4w minus 3w, that will give us 1w or w, plus 5w will give us 6w. Then we have 4h minus 6h, that will give us negative 2h. So we have negative 2h over here. Now if we look at our answer, we realize that there is a common factor that can divide every coefficient over here. So there's a factor that can go into 10, 6 and 2 at the same time, and that number is 2. So we factor 2 out, then into bracket we have 5l plus 3w minus h. So it means if we use 2 to expand the bracket, we are going to get what we have at the top over here. So this becomes our final answer. After we've expanded the bracket, we had this expression, we rearrange the expression, we simplify the expression, and then we factor out the common factor to get our final answer. So this is how we factorize simple algebraic expressions in mathematics. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to multiply algebraic expressions. Alright, so let's start by looking at an example. So we have 3p squared qr multiplied by 4p q cube multiplied by 5qr squared. Alright, so if we have an expression like this and we are to multiply the expression, how do we go ahead to solve this problem? Now there are so many ways you can do this, it depends on you. Now there is something we call multiplication. Multiplication is commutative. That is one of the properties of multiplication. This simply means that if you have 3 multiplied by 4 and you write 4 multiplied by 3, you are still going to get the same answer. You're still going to get the same answer, which is 12, by the way. 12, 12. So it doesn't matter how you rearrange it, you're still going to get the same answer. Now if you look at all the terms we have here, they are all multiplying each other. So I can decide to multiply, group all of these terms one by one and multiply all of them. So by that I mean I can decide to write 3 multiplied by p squared multiplied by q multiplied by r, because that is actually what is happening here, multiplied by 4 multiplied by p multiplied by q cube multiplied by 5 multiplied by q multiplied by r squared. I can decide to do it like that. Now if I expand it like this, then I can decide to multiply number by number, then each term or variable by the other. So I have numbers over here, I have 3, so I can write 3 multiplied by 4 multiplied by 5 as 1. Let me put that in bracket. Then multiply, I have p here, so I can multiply the p squared multiplied by this p multiplied by, okay, that is the end, so this one closes over here. Then I open another bracket, I go to q multiplied by another q here, q multiplied by another q. Then the next one is r, I have r multiplied by r squared. Okay, so from here I can go ahead and do my multiplication and get my final answer. So 3 multiplied by 4 will give me 12. 12 multiplied by 5, that will give me 60. So I have over here 60. Now p multiplied by p squared multiplied by p will give me p cube. Okay, so this multiplication with exponent, this has the power of 1. So because there's multiplication in between them, you add their powers, indices. So this becomes p cube. Then I have q cube, q. So this is power 1, power 1. So I just add the powers. That will give me 5. 1 plus 3 plus 1 will give me 5. So this becomes q power 5. Then I have r, this is power 1, this is power 2. So r power 3. So this becomes my answer. I can do it this way, or straight ahead from here, I can say 3 multiplied by 4 multiplied by 5. That will give me 60. Then p multiplied by p squared multiplied by p, that will give me p cube. Then q multiplied by q cube multiplied by q, that will give me q power 5. And then r multiplied by r squared will give me r power 3. Okay, so I can also do it like that and get my final answer. Okay, so either I do it direct by multiplying, or I decide to break all of them down, regroup them, and then do the final multiplication. I'm still going to get the same answer. Alright, so let's go ahead and look at more examples to see how to do multiplication. Alright, so we have to perform the following multiplication and simplifying the answers where possible. So the instruction is for us to perform the following multiplication. Simplifying your answers. Alright, so the first one we have over here is 2xy multiplied by 3x squared y. The second expression is 5a squared bc cubed multiplied by 2ab squared multiplied by 3c. Then we have I. We have km multiplied by mn multiplied by nk. Then iv, the fourth one, we have 3pq squared r multiplied by 6p squared qr multiplied by 9pqr squared. Then the final one, we have rs multiplied by 2st multiplied by 3tu multiplied by 4ur. Okay, so these are the examples that we have to multiply. So let's go ahead and look at the solution. Now you can try this on your own and then compare the final answer with mine. So you can pause the video and then do the multiplication and compare the answer at the end of this tutorial. Right, I'm sure you are done, so let's proceed. So we have 2xy multiplied by 3x squared y. Right, so for the sake of this tutorial, I'll be breaking them one by one. So I will multiply the number by number, each variable by each variable. So I will have 2 multiplied by 3, then x multiplied by x squared, then I have y multiplied by another y. So this is equal to 2 multiplied by 3, that will give me 6. X multiplied by x squared, this has a power of 1, so I add the powers, so it becomes x power 3. Then y power 1 becomes power 2. So my final answer is 6x cubed y squared. Alright, so the second example, I have 5a squared bc cubed multiplied by 2ab squared multiplied by 3c. So as usual, I'm going to group my numbers together. So 5 multiplied by 2 multiplied by 3, then a squared multiplied by a, then b multiplied by b squared, then c cubed multiplied by c. Alright, so 5 multiplied by 2, that will give me 10. 10 multiplied by 3, that will give me 30. So I have 30. This has a power of 1. This also 1. This also 1. So I have A, B, and C. Now for their powers, A squared multiplied by A power 1 will give me A power 3. So this is A3. B multiplied by B squared will give me B, also 3. And then C power 3 multiplied by C will give me C power 4. Just add their powers. So this is my final answer for the second expression. Now let's go ahead and look at the third expression. So I have I Km multiplied by Mn multiplied by Nk. Right, so here I have K multiplied by this K, then into bracket this first M multiplied by the M over here, then this N multiplied by the N over here. So this will give me K squared, M squared, N squared as my final answer over here. Right, so let's proceed to look at the fourth and then the last expression. So the fourth expression we have is IV, that is 3pq squared r multiplied by 6p squared qr multiplied by 9pqr squared. Right, so this is equal to, I multiply the numbers separately, so 3 multiplied by 6 multiplied by 9. Then I have p multiplied by my p squared over here multiplied by this p over here. Then I have my q squared multiplied by this q over here multiplied by the q over here. And then I have this r multiplied by r squared. So r multiplied by r multiplied by r squared. Alright, so 3 multiplied by 6 multiplied by 9, that will give me a total of 162. Then this p has power 1, 1, 1, 1, and 1. So this, I'll just add the power. So 1 plus 2, that is 3, plus 1, that is 4. So here becomes p power 4, q 2 plus 1 plus 1, that is 4. So q power 4. And then r also power 4, that is 1 plus 1 plus 2. So this is my final answer. Right, so let's look at the last expression. We have rs multiplied by 2st multiplied by 3tu multiplied by 4ur. As usual, I need to multiply my numbers and then each variable by the other. So I have 2 multiplied by 3 multiplied by 4, then r multiplied by another r over here. Then I go to the s term, so s multiplied by the second s over here. Then the next variable is t, so I have t, the first t multiplied by this t, and then I have u, so u multiplied by another u, u by another u. Okay, so 2 multiplied by 3, that will give me 6, 6 multiplied by 4, that will give me 24. R multiplied by r will give me r squared, s multiplied by s will give me s squared, t multiplied by t will give me t squared, and then u multiplied by u will also give me u squared. So this is my final answer. So this is how you go around multiplying algebraic expression if you've been given any expression like that. So thank you so much for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn how to simplify algebraic expressions. So let's begin. So let's say we are to simplify the expression. We are to simplify the expression x on 2 minus 2y on 10 plus z on 4. Alright, so for us to simplify this expression, we need to first of all identify that these fractions are unlike fractions. It means they don't have the same denominator. So for us to be able to proceed to add or subtract, we need to find a common denominator for them. We can do that by using or finding something we call the LCM, which stands for the least common multiple. The least common multiple. How that works is we write all the denominators, so we have 2 here. Then we write the multiples of 2, so we have 2, 4, 6, 8, 10, 12, 14, etc., etc. Then we write 10. We also write the multiples of 10, so we have 10, 20, 30, 40, then it continues. Then we take 4. We also write the multiples of 4, so we write 4, 8, 12, 16, 20, 24, etc. Now what we need to do is that, okay, so let me continue that of the 2. So for the 2, we have from 14, we have 16, 18, 20, 22, etc. So if we look at it, we realize that we go through all of this. What we need to do is we go through all of this to find the common multiples, which means the numbers that are common for all of them. So the common multiple CM, in our case over here, if we look through the first one, we can see there is 10 here, there is 10 here, 10 is not here, 8 here, 8 here, but no 8 here. But we can see 20 over here, we can see 20 here, we can see 20 here, so we write 20. Alright, so which other number can we see? Now if we were to extend or continue writing this, we will get other common multiples, but as at this time, since we already have the smallest that we can possibly find so far, this becomes our LCM, or our least common multiple, which is now 20. So it means that they will all have a common denominator of 20. Now we need to express all these fractions as on 20. So what that means is that we take the denominator here 2. How many times will 2 go into 20? It will go there 10 times. We use the 10 to multiply the numerator over here. So we get 10x, then minus 10 will go into 20 how many times? 2 times. Then we use that 2 to multiply the 2y we have over here. So we get 4y plus how many times will 4 divide 20? 4 will go into 20 5 times. So we use that 5 to multiply the z over here. So we get 5z. So from here, we can go ahead and try to simplify if we have anything to simplify. So if we look at all this expression, this is an x term, this is a y term, this is a z term. We have 3 different variables. There's nothing we can add, there's nothing we can subtract. So our final answer is 10x minus 4y plus 5z all on 20. So this becomes our solution for the first example. Alright, so let's go ahead and see how we can simplify another set of fraction. So assuming we have x squared on y minus y squared on x. Alright, so if we are to simplify this expression, how are we going to do that? So we are to simplify this. The first thing we need to do, as always, is to find a common multiple. For this example, because these are 2 variables, we multiply them and then they become the least common multiple. So if we multiply y by x, we get xy. Now it means that if we divide xy by y, we are going to get just x left. So that x, we use it to multiply what we have over here. So we get s cubed minus, we have x here. If we divide this xy, if we divide x by the xy, we'll get only y. So we use that y to multiply the y squared over here. So we get y cubed. So this becomes our final answer. Let's look at another expression. So we are to simplify 3x squared on 5y multiplied by 5y squared, 5yz on 6x. Alright, so for this particular expression, if we look at this very well, we can see that there are some things that we can cancel. So we need to cancel out some numbers and some variables. We can do that. So let me try and rewrite this expression in a way that is easier for us to cancel or to nullify some terms. So I have 3x squared over here. I can write that as 3x multiplied by x. Okay, 3x multiplied by x on 5y. Then this multiplication sign, then 5y multiplied by z on, over here this is 6x, so I can write that as 3x multiplied by 2. That will still give me 6x. So from here I can say that this 3x will cancel the 3x over here, the 5y here will cancel this 5y over here, so I'm left with x on 1 over here multiplied by z on 2 over here. So if I proceed and I multiply everything here, I am going to get xz on 2 as my answer after simplifying this expression. Alright, so let me proceed to give more examples on how to simplify these expressions. So say I have x minus 1 cube on 4x x minus 1. How am I going to simplify this particular expression? Now, for you to simplify this expression, you need to write the numerator that you have, which is x minus 1 all raised to the power cube. You need to expand that bracket or write it in a form that is easier for you to cancel. What I mean by that is, we can write this, the numerator, as x minus 1 multiplied by x minus 1 all squared. I can rewrite what I have at the top here as this over here. Then I can now divide it by 4x into bracket x minus 1. Now I have a common term at the numerator, I have a common term at the denominator that can cancel each other out. So this will cancel this, and I'm left with x minus 1 squared on 4x as my final answer. Alright, so let's say I have 24x plus 6 on 3 into bracket 4x plus 1, and I'm to simplify this particular expression. How do I go around simplifying this expression? Now if you look at this, it's not simply direct. There is something you need to do. We can see that there's an expression at the bottom here, 4x plus 1. Now let's try to manipulate the numerator in a way that we can factor a number out, get the expression 4x plus 1 at the top so that we can cancel out. Now if we look at that, the only thing we can do at the top is to factor 6 out. If we factor 6 out, we have 6 outside bracket, then into bracket. What number will you multiply by 6 to get 24? That is 4. So we have 4x over here. Then plus, what number will you multiply by 6 to get 6? That is 1. So it means 24x plus 6 can be written as 6 outside bracket, then into bracket 4x plus 1. That is, we factored out 6. Now I can now divide this by 3 into bracket 4x plus 1. So from here, this can cancel this. Now I'm left with 6 on 3, and this will give me the answer 2 as my final answer after simplifying this expression. Right, so now that we have the basics of how to simplify various algebraic fractions, no matter how the expression is given, let's go ahead and solve this particular example. So we have to simplify the following expression. 1, 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. The second expression is kmn on 3n cubed multiplied by 6k squared m cubed on 2k cubed m. Then the last expression is 2fg on 16h multiplied by 4gh squared on 4fh multiplied by 32 fh cubed on 12f cubed. Alright, so these are the expressions we are to simplify as much as possible. So let's go ahead and simplify these expressions. Now you can pause the video and try your hands on these expressions to see what you get as your answer. Alright, so let's go ahead and tackle the first one. So for the first one, the expression is 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. Now, straight ahead, we can cancel some things out, some numbers, some variables that are common. We can cancel them out and have our expression easier for us to simplify. So I can cancel y with the y at the top over here. I can cancel the z at the bottom with the z at the top here. I can cancel the x here with the x here. So straight ahead from the beginning, I've cancelled all the variables. So I'm left with 3 multiplied by 8 multiplied by 5 on 2 multiplied by 3 multiplied by 4. Or still from here, I can cancel this 3 with this 3 over here. I can cancel this 4, okay, with this 8, but to be left with 2. So 4 will go into 8 2 times. And then I can cancel this 2 with this 2 now. So I'm only left with 5 at the top over here. So straight ahead, my answer is 5. So this is how easy it is when you have fractions and they are multiplying each other in algebraic expression. You can cancel things out. Just take your time and do the cancellation. Alright. Or another way you can do that is, let me redo that. So I can write 3x on 2y multiplied by 8y on 3z multiplied by 5z on 4x. Another way you can do this is to multiply everything you have and get your answer. So you can do that by multiplying 3 by 8 by 5. So we have 3 multiplied by 8 multiplied by 5. Then you attach the variables, that is x, y, z. Then all on 2 multiplied by 3 by 4. So 2 multiplied by 3 multiplied by 4. Then you attach the variables y, z, and then x. So at the end, you realize that this will cancel this because they are the same term. 3 here will cancel this over here. 2 here will go here 1. It will go here 4. So you are left with 4 multiplied by 5 on another 4 here. And then this 4 can cancel this 4. And then you get 5 as your answer. So there are so many ways you can go around to cancel or to multiply and get your final answer. It depends on you. If you like, you can cancel straight ahead as in this first example, and then you get your final answer. Or if you like, you multiply everything before you cancel and then you do your final substitution. Alright, let's tackle the second expression. So we have kmn on 3n cubed multiplied by 6k squared m cubed on 2k cube m. Alright, so as usual, we can go ahead and start cancelling some, maybe n here, m here, m here. We can do that, or we can go ahead and multiply everything, the numerator by the numerator, the denominator by the denominator, before we cancel. So let's do that in this case. If I multiply everything by everything I have at the top here, I'm going to have 6. K multiplied by k will give me k cubed. M multiplied by m will give me m power 4. Then n. All divided by 3 multiplied by 2 will give me 6. Then I have n cubed because there's no n here. Then I have k cubed. Then m. Alright. So from here, I can go ahead and start cancelling to get my final answer. So the 6 will cancel the 6 out over here. Then the k cube will also cancel the k cube over here. So I have m power 4n over m n cube. Alright, so one of this m will cancel one of this m over here. So we'll be left with m power 3. And then this n will cancel one of the n over here. So it will be divided by n squared. So our final answer is m cubed over n squared as our final answer. Alright, let's proceed to look at the last expression that we have over here. So let me get some space. Alright, so the third expression we have is 2fg on 16h multiplied by 4gh squared on 4fh multiplied by 32fh cubed on 12f cubed. Alright, so there's a simpler way we can do this. We can start off by cancelling so that it makes things easier for us. So let's do the cancellation. So this 4, let me use another color. Alright, so the 4 here can cancel the 4 over here. Then the 16 over here can go into itself 1. It will go into 32 here 2 times. The 2 go into itself 1. It will go into 12 6 times over here. So what we are left with is now fg on h from here, the top over here, multiplied by over here we have gh squared on fh, then multiplied by here we have 2 on 6, here fh cube, here f cube. Alright, so from here we can go on ahead and start cancelling some things again. So this h here can cancel one of the h over here, so we are left with just one h. The f here can cancel the f here. Then the small h here will cancel the last h we have over here. And then we have one g over here. We have another g over here. Now we have f here. 1 will cancel this, so we have f squared left over here. So from here, the only thing we have is g and g. So we have g multiplied by g multiplied by 2h cube here on over here we have 6f squared. So g multiplied by g will give us g squared. We have h cube, we put a 2 in front of it, then we have 6f squared. And then you know that this 2 will go into itself 1, it will go into 6 here 3. So our final answer will be g squared h cube on 3f squared. So this becomes our final answer. Now, like I said, you can take your time and cancel one by one and rewrite what you have, cancel again, rewrite like that until you get your final answer. Or you can multiply everything you have at the top, multiply everything you have at the bottom, then you have some bulk numbers and variables, and then you take your time to cancel them out individually to get your final answer or your final expression. Right, so let's go ahead and look at more examples. Alright, so we have to simplify the following expression. We have the first expression, we have x plus 1 on 4 plus x minus 1 on 2. The second expression, we have x plus 3 on 2x plus 6. The last expression we have to simplify is we have 6 outside bracket 2x plus 1 squared on 3 into bracket 2x plus 1 all raised to the power of 5. Alright, so let's go ahead and simplify these expressions one after the other. So solution. Now you can pause the video, go ahead and simplify this expression, and then we compare our answers at the end. Alright, so the first expression, we have x plus 1 on 4 plus x minus 1 on 2. Now we have two different fractions that we are supposed to add. They have different denominators, so they are unlike fractions. So we need to find a common denominator for them. Now if we look at 4 and 2, the common denominator for them will be 4. Now the 4 will go into the 4 here just once. So we have that 1 multiplied by the top. We have 1 into bracket x plus 1. Then 2 here will go into 4 two times, so we have plus that 2, you use it to multiply the numerator, so I take it again. The 2 here will divide the 4 here 2 times, so we have 2 into bracket x minus 1 at the top over here. Now we can expand the bracket and then simplify our expression. So if we use 1 to multiply everything here, we get x plus 1, then plus 2 to multiply here, we have 2x minus 2 all on 4. So this is equal to s plus 2s, that will give me 3s, 1 minus 2, that will give me minus 1 on 4. So this becomes my answer for the first expression. Alright, I have x plus 3 on 2x plus 6. Now whenever you have an expression like this, if you look at it very well, you see that there is nothing you can cancel easily, so you need to factor something out. Or write this expression in a way that you have something common at the top and at the bottom that you can cancel. So if you look at it, the top, there's nothing much we can do, so we maintain that x plus 3, but at the bottom we can factor something out. So if we factor 2 out, we are left with 2 outside bracket, then x plus 3, that is 2 multiplied by x will give us 2x, 2 multiplied by 3 will give us 6. Now I have x plus 3, x plus 3 over here, so I can cancel them. So this cancels this. So over here at the top we are left with 1, and then at the bottom we are only left with 2. So our answer for the second expression is half. Alright, let's go ahead and tackle the last expression. So the last expression, we have 6 into bracket 2x plus 1 squared on 3, then 2x plus 1 raised to the power 5. As usual, we need to rewrite these expressions in a way that is easier for us to cancel some things out. So if we look at it very well, I can decide to factor something out at both the numerator and the denominator. So I've decided to rewrite the 6 over here as 2 multiplied by 3 into brackets 2x plus 1 all square. Okay, this is the same thing. It means 2 times 3, which will give me the 6 over here. Then on over here, I can decide to rewrite this as 2x plus 1 raised to the power 3, then multiplied by 3 raised to the power 2x plus 1 all squared. All that I've done here is I've rearranged this expression. So I've rewritten the 2x plus 1 raised to the power 5 as 2x plus 1 squared multiplied by 2x plus 1 cubed. So if this multiplied by this will give me this. Okay, so this expression I've rewritten it as this, and I've decided to bring the 3 here in front of the first one over here. I've decided to bring the 3 in front of it over here so that it makes the expression easier. So from here I can see that this and these are the same, so I can go ahead and cancel them. So once this and this cancels each other out, we are left with 2 at the top on, then I have 2x plus 1 all cubed at the bottom as the answer for the last expression. So thank you so much for watching. This is just a brief examples on how to simplify fractions in algebraic expression. Now we'll be looking at part 2 of this tutorial, where we'll look at more complex fractions and how we go around simplifying all those expressions. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at the second part of how to simplify algebraic fractions. So let's go ahead with an example. So we are to write the following as single fraction. So write the following write the following as single fractions. So that is our instruction. Then we have I, or Roman numeral 1, 2x on 3 minus x minus 1 on 5. Roman numeral 2, we have 3x minus 5 on 4 plus x minus 7 on 6. Then our third expression or fraction is 3 outside bracket 2x plus 1 on 5 minus 7 outside bracket x minus 2 on 2. Then our last expression is 4x plus 1 on 8 plus 7x on minus 3 on 12. Alright, so this is the expressions we have to write as single fraction. So let's go ahead and proceed to see the solution for these examples. So the first example, so we have 2x on 3 minus x minus 1 on 5. So now if you look at this expression, we realize that we have two different fractions, unlike fraction in that case, because they have the denominators are not the same, and we have to subtract them. For us to do that, we need to find a common denominator for them. That is what we call the LCM. Now the LCM for 3 and 5 is 15. So what we do is, now we divide the 3 by the 15, we divide the 15 by 3, divide the 15 by 5. Whatever we get, we use it to multiply their numerators respectively. So that means 15 divided by 3. How many times will 3 go into 15? It will go 5 times. So we use that 5 and we use it to multiply the 2s at the top over here. So we have 5 multiplied by 2s minus this 5 will go into 15 3 times. So we use that 3 and we use it to multiply the numerator we have over here, x minus 1. So this is equal to 5 multiplied by 2 will give us 10x minus 3 multiplied by x will give us 3x. 3 multiplied by negative 1 will give us positive 3, all on 15. Now we have two variables, common variables over here, 10x and 3x, so we can easily subtract them. So 10x minus 3x, this will give us 7x plus 3 on 15. So our final answer for the first expression is 7x plus 3 on 15. Now let's proceed to look at the second expression. So just like we did for the first expression, we are going to do something similar for the second expression. So as usual, we need to find a common denominator for the two of these numbers, that is 4 and 6, and then the common denominator is 12. So 4 will go into 12. How many times? It will go there 3 times. So we use the 3 to multiply the numerator, that is 3x minus 5 here. Then plus 6 will go into 12 2 times. We use that 2 to multiply the numerator we have over here, that is x minus 7. So from here we can expand the bracket and simplify our expression to have our final answer. So 3 multiplied by 3 will give me 9x. Then minus 3 multiplied by 5 will give me 15. Plus 2 multiplied by x will give me 2x. 2 multiplied by negative 7 will give me 14. All on 12. So from here, I have 9x, I have 2x. So 9x plus 2x will give me 11x. I have negative 15, negative 14. That will give me negative 29. So I have minus 29 on 12. So if I look at this expression, there is nothing much I can do to this expression to simplify it any further, because this is 11x, it has a variable attached. This is just a negative number without any variable, so there's nothing we can do about it. So this becomes our final answer for the second expression. Right, so let's proceed to look at the third expression that we have over here. Let's look at the answer for that. Alright, so for our third expression, we have 3 outside bracket 2x plus 1 on 5 minus 7 outside bracket x minus 2 on 2. Now, what I will recommend for you to do first is to first expand the bracket to have the numerators in a linear form before you go ahead and find their common denominator and simplify the expression. So I'll do that. So 3 multiplied by 2x will give me 6x plus 3 multiplied by 1 will give me 3, then divided by 5 minus 7 multiplied by x will give me 7x, 7 multiplied by negative 2 will give me minus 14 on 2. Now from here I can now go ahead and find my common denominator. Now this is 5. Let me write that well. This is 5, not 6. It's 5. Okay. Now between 5 and 2, the common denominator for them is 10. So now 5 will go into 10 2 times. So we use that number 2 to multiply the new numerator we have over here. That is 6x plus 3. Then minus 2 will go into 10 how many times? 5 times. So we use that number 5 to multiply what we have at the numerator here. So 7x minus 14. So from here we can now expand the numerator over the common denominator we have, simplify the expressions and get our answer. So 2 multiplied by 6x will give me 12x. 2 multiplied by 3 will give me 6. Then minus 5 multiplied by 7 will give me 35x. Then negative 5 multiplied by negative 14 will give me positive 70 as my answer. So all divided by 10. Now if you look at it, we have 12x, we have negative 35x. So 12 minus 35x will give us negative 23s, and then I have 6 plus 70, that will give me 76 over 10. Okay, so from here, okay, I can rearrange this so that I have the 76 coming first. So I have 76 minus 23x over 10 as my answer for the expression, or the third example that we have over here. Either you leave it here or you rearrange it and get it here, the answer is still the same. Alright, so let's have a look at the final expression that we have over here in this first example. So let me clean everything. Alright, so the last expression that we were given, IV, is 4x plus 1 on 8 plus 7x minus 3 on 12. Alright, so as usual, we find a common denominator for both 8 and 12. That will be 24. 8 will go into 24 3 times, so we have the 3 outside bracket. Use it to multiply 4x plus 1, then plus 12 will go into 24 2 times, so we write the 2 outside, then we multiply it with 7x minus 3 over here. Now 3 multiplied by 4 is going to give me 12x. 3 multiplied by 1 will give me 3. 2 multiplied by 7 will give me 14x. 2 multiplied by negative 3 will give me negative 6, all on 24. So from here I have 12x positive 14x, that will give me a total of 26x. Then I have positive 3 minus 6, that will give me negative 3, all on 24. So this is my answer for the last expression. Now let's have a look at some more examples. So we have to simplify the following expressions. So simplify the following expressions. So we have I, 2x into bracket y minus 3 raised to the power 4 on 8x squared y minus 3. Then we have 6x minus 12 on x minus 2. Then the last expression, we have 3x plus 2 squared on 6x plus x power 4 on 6x plus 4. Alright, so this is the expression we have to simplify. So let's go ahead and look at our solution. Now you can kindly pause the video, solve the expressions, get your answer, then we do it together, and then we see our final answer together. Alright, so let me start with the first one. So I have 2x y minus 3 raised to the power 4 on 8x squared y minus 3. Alright, so this is pretty easy, pretty straightforward. I need to express the numerator and the denominator in a way that is easier for me to cancel some things out or some variables out. So I have 2x over here. I can rewrite 8x squared in a way that I will have only 2x. So let me write the numerator first. So I can rewrite 2x here. Over here I have y minus 3 power 4. Here only y minus 3. So I can rewrite this as y minus 3, then another y minus 3 raised to the power cube. So this multiplied by this will give me y minus 3 raised to the power 4. So I've not done anything to the numerator. Then divided by the 8x squared I have over here. I can rewrite it as 2x multiplied by 4x. So 2x by 4x will give me 8x squared. Then I have y minus 3 over here. So from here I can see that the 2x can cancel this 2x, y minus 3 will cancel this y minus 3. So I'm left with y minus 3 cube at the top, and then at the bottom only 4x. So that becomes my final answer for the first expression. Alright, let me look at the second expression. Let's look at the second expression. So we have 6x minus 12 on x minus 2. So just like how we saw in the previous example, when we have an expression like this, we need to rewrite it in a way that we can cancel something from the numerator and then the denominator. We do that by looking at where we think we can factorize. We factor something out to get a common variable at the numerator and then the denominator, then we cancel out. So if we look at the numerator we have over here, we can factor something out and get the expression in the form x minus 2. So let's see, if we factor 6 out over here, we have 6, then into bracket we have x here minus 2. So it means 6 multiplied by x will give me 6x. 6 multiplied by negative 2 will give me negative 12, as I can see over here at the numerator. So this will now be divided by x minus 2. So from here I can cancel these guys out. So my final answer is now 6 on 1, which is equal to 6. Alright, so let's have a look at how we simplify the last expression. So the last expression we have, you can see it over here. This is our last expression. So let's go ahead and look at that. So we have 3x plus 2 squared on 6x multiplied by x power 4 on 6x plus 4. Alright, now someone will be tempted from here to go ahead, multiply this by this, get it as LCM, and then you go ahead and simplify. Now that won't work too much for you. If you look through the expression really well, you see that there are some things you can cancel out, but it needs you have to rearrange the equations so that you can cancel some things out. So I'll break the numerator I have over here. I'll rewrite them in a much more linear way. So I have 3x plus 2 multiplied by another 3x plus 2. So that will give me what I have at the top over here, then divided by 6x multiplied by x power 4 here at the top. Then the denominator over here, I can express it as, I can factor something out so that I have 3x plus 2 expression over here at the bottom. So if I factor out 2 over here, I'll have 2 outside bracket, then I have 3x plus 2 in here. So this multiplied by this will give me 6s, 2 multiplied by 2 will give me 4 over here. Now that the expression is like this, one of these guys can cancel one of these guys out. Now the x power 4 over here, I can rewrite it as x multiplied by x cubed. That is the same as the x power 4 here. So this 1x over here will cancel this x over here. So I'm left with 3x plus 2 at the top here. So I have 3x plus 2 at the top here on 6 multiplied by s cubed on 2 over here. So my final answer will now be s cubed multiplied by 3x plus 2 all on 6 multiplied by 2 will give me 12. So this becomes my answer for the last expression. So thank you so much for watching. Hello and welcome to my science tutorials. In today's video, we want to look at linear equations and how to solve problems on linear equation. Alright, so let's start by looking at an example. We have to solve the equation given below. Solve the equation. Five into bracket x minus 3 is equal to 2 into bracket x plus 6. So this is the equation that we've been given, and we have to solve for the equation and find the value of x. Now we can see that for a linear equation we have the right hand side and then the left hand side, and there's an equal to sign in between them. What this means is that whatever we get on the right hand side is supposed to be the same as the left hand side, so they are all the same. So if we find x and we substitute the value of x, we should get the same answer on both sides of the equation. Now for us to tackle this problem, the first thing we need to do is to expand the bracket. So we use the 5 to multiply the content in the bracket over here. So 5 multiplied by x will give us 5x. 5 multiplied by negative 3 will give us negative 15. This is equal to 2 multiplied by x will give us 2x. 2 multiplied by positive 6 will give us positive 12. Now from here, we can see that there is a variable attached to this number and then the same variable attached to another number over here. So we can group like terms. By like terms, it means we bring the numbers with the variable to one side of the equation and just numbers to the other side of the equation. For the sake of this tutorial, I'll be moving this 2x to the left hand side of the equation. So I have 5x over here. If I bring the 2x across the equal to sign, it becomes negative. So minus 2x is equal to, the 12 will be maintained here, and I bring the negative 15 over here to the right hand side of the equation. So if I bring the negative to the other side of the equation, it becomes positive 15. Now 5x minus 2x will give me 3x. This is equal to 12 plus 15 will give me 27. Now if I divide both sides by 3, I will get the value of my x to now be 27 divided by 3 will give me the value of 9. Now once you are done and you find the value of the variable that you've been given to find, always make sure you cross check to see if the left hand side is equal to the right hand side. So the left hand side over here, the equation that we have is 5 into bracket x minus 3, and then on the right hand side we have the equation 2 into bracket x plus 6. Now we found out that our x is 9, so let's do the substitution and see if it's going to be the same. So 5 into bracket 9 minus 3, this is 5 into bracket 9 minus 3 will give us 6. 5 multiplied by 6 will give us 30. Right, so let's look at our right hand side. We have 2x plus 6. So 2 multiplied by x, which is 9, plus 6. This is equal to 2 multiplied by 9 plus 6 will give us 15, and 2 multiplied by 15 will give us 30. So we can see that the right hand side is indeed equal to the left hand side, and this verifies that our answer is correct. Now assuming you do the substitution and you get, let's say over here 32 and then here to be 30, then it means the value of your answer or your x is wrong. So you need to redo the calculation to find your answer. All right, so let's look at another example. So we have to solve the equation 1 over 2 into bracket x plus 6 equal to x plus 1 over 3 into bracket 2x minus 5. Okay, now when we have an equation like this, we realize that we have a fraction in the equation, so we need to get rid of the fraction. We do that by multiplying each term by the LCM or the common factor for 2 and 3. So if we do that, we realize that we have, this is the first term, this is the second term, this is the third term. We have 3 different terms, so we use the LCM to multiply through each of the terms. So the LCM of 2 and 3 is 6, so we use 6 to multiply 1 over 2 into bracket x plus 6. Since all of this is one term, is equal to 6 multiplied by x will give us 6x plus 6 multiplied by 1 over 3 into bracket 2x minus 5. Now we can simplify and then expand the bracket. So 6 multiplied by half will give us 3, and then into bracket x plus 6 is equal to, we have 6x here plus 6 multiplied by 1 over 3, that will give us 2, then into bracket 2x minus 5. From here we can now expand the bracket and find the value of x. So 3 multiplied by x will give me 3x plus 3 multiplied by 6 will give me 18. This is equal to 6x plus 2 multiplied by 2x will give me 4x. 2 multiplied by negative 5 will give me negative 10. Right, so from here I need to group items. It means I need to bring all the numbers with variables to the one side of the equation and then just numbers to the other side of the equation. Right, for the sake of this tutorial, I'll maintain the 18 over here and bring the negative 10 to the left hand side of the equation, so it becomes plus 10 is equal to, I still have these guys here, 6s plus 4x, then I send the positive 3 over here to the right hand side, it becomes negative 3x. So 18 plus 10, this will give me 28, is equal to 6 plus 4, that will give me 10, minus 3 to give me 7x. So from here I now divide 2 by the coefficient of the x term so that the x will stand alone. So I divide both sides by 7, and then x will give me 28 divided by 7 will give me the value 4. Now that I found my answer, I need to cross check to see if it is correct. So I need to check my left hand side and see my right hand side and see whether they are the same. So the original equation is half multiplied by x plus 6, that is for the left hand side, and then the right hand side is x plus 1/3 of 2x minus 5. Alright, so let's do that. So we have half 4 plus 6, this is half multiplied by 10, and this will give us 5. Right, on the right hand side we have x, which is now 4, so we have 4 plus 1 over 3, 2 multiplied by 4 here, minus 5. So we have 4 plus 1 over 3, 2 multiplied by 4 will give us 8, minus 5, that will be 3. Now 1/3 of 3 is 1, so we have 4 plus 1/3 of 3 is 1. So this will give us the final answer of 5. So we have 5 on the left hand side, 5 on the right hand side. So this means our answer, which is x is equal to 4, is correct. Now mind you, your answer is x is equal to 4 and not the 5 you've done over here. This 5 and 5 is just to verify. It's just a verification that your answer, which is 4, is actually correct. So never confuse that and write after verification, don't write the answer you got for the verification as your answer. Just use the value that you used to do the substitution. Alright, so let's look at some examples to try our hands on. So we have to solve the following equation. Solve the following equation. So we have I, 5 outside bracket 2d plus 8 is equal to 2 into brackets 3d plus 24. I, half k plus 1 over 4k is equal to 36. I. We have n plus 1 over 3, n plus 1, this is 1, plus 1 over 4, n plus 2 is equal to 5 on 6, and then IV, 1 over 2, L minus 5 plus L is equal to 11. Alright, so you can pause the video, go ahead and try your hands on these following equations, get your answers, and then we compare at the end of this video. Alright, so let's go ahead and look at the solution for these problems. So let's write down our solution. So we have 5 outside bracket 2d plus 8 is equal to 2 outside bracket 3d plus 24. Alright, so the first thing we need to do is to expand the brackets. So we use 5 to multiply the content of this bracket on the left hand side. So 5 multiplied by 2d will give me 10d, plus 5 multiplied by 8 will give me the value 40. Is equal to 2 multiplied by 3d will give me 6d, plus 2 multiplied by 24 will give me 48. So from here I can group item. So I maintain the 10d over here, I bring the 6d to the other side, so it becomes negative 6d is equal to, I maintain the 48 here, then I send the positive 40 to the right hand side, it becomes negative 40. Now 10d minus 6d will give me 4d is equal to 48 minus 40 will give me 8. Now because I want the value for the variable d, I divide both sides by 4, which is the coefficient of the d term here, to cancel this guy out. So my final answer for d is 8 over 4, and that will give me the number 2. So the value of d in the first example is 2. Now you can cross check to verify if the left hand side is equal to the right hand side. You still get the same answer for them. So let's proceed. So we have 1 over 2k plus 1 over 4k is equal to 36. Alright, so over here the first thing we need to do is to get rid of the fractions. We do that by multiplying through by the LCM. So the LCM for 2 and 4 is 4. So we use 4 to multiply half k plus 4 multiplied by 1/4 of k is equal to 36 multiplied by 4. Now 4 multiplied by half will give me 2, so it becomes 2k, plus 4 will cancel this 4 out, so we only have k here, is equal to 36 multiplied by 4 will give me 144. So 2k plus k will give me 3k is equal to 144. I divide both sides by 3, and then my value for k becomes 144 divided by 3 will give me the value of 48 as my answer for k. Alright, so let's proceed to look at the third example. We have n plus 1 over 3, n plus 1 over 4, n plus 2 is equal to 5 on 6. Alright, so the first thing we need to do, as usual again, we find the LCM. Since we have fraction 1 over 3, 1 over 4, and 5 over 6, we multiply through by the least common multiple, the LCM. The LCM for 3, 4, and 6 is 12. So we use 12 to multiply each individual term over here. So it becomes 12 multiplied by n that will give me 12n, plus 12 multiplied by 1 over 3 into bracket n plus 1, plus 12 multiplied by 1 over 4 n plus 2 is equal to 12 multiplied by 5 on 6. So I still have my 12n here, plus 3 will go into 12 4 times, so it becomes 4 into bracket n plus 1. 4 will go into 12 3 times, so it becomes plus 3 into bracket n plus 2 is equal to 6 will go into 12 2 times, so 2 times 5 will give me 10 over here. Alright, so from here I can now expand the bracket, group like terms, and then simplify my expression. So I have 12n plus 4 multiplied by n will give me 4n, 4 multiplied by 1 will give me 4, plus 3 multiplied by n, 3n, 3 multiplied by 2 is 6. This is equal to 10. So I have 12n, 4n, and then 3n over here. So 12n plus 4n will give me 16n, plus 3n will give me a total of 19n. So this becomes 19n is equal to 10. Now I can send the 4 and then the 6 over here to the other side of the equal to sign, so it becomes minus 4 minus 6. So I have 19n is equal to 10 minus 4 is 6, minus 6 becomes 0. So I divide both sides by 19, and then my final answer n will be equal to 0, because 0 on any number is equal to 0. So the value of n in this example is 0. Alright, let's look at our last example, IV. So we have 1 over 2 multiplied by L minus 5 plus L is equal to 11. Alright, so we multiply through by the LCM, which is 2 in this case. So it will be 2 multiplied by 1 over 2 into bracket L minus 5 plus 2 multiplied by L, that will give us 2L, is equal to 11 multiplied by 2. So this cancels this out. So we have L minus 5 plus 2L is equal to 22. Now, L plus 2L will give me 3L is equal to 22. Then I send the negative 5 here to the right hand side, it becomes positive 5. So I have 3L is equal to 22 plus 5 will give me 27. I divide both sides by 3, and then I get my value for L to be 27 divided by 3 will give me a value of 9 as my answer. So this is how you solve linear equations. Always make sure that after getting your answer, you substitute it back into the left hand side and then the right hand side to see if you get the same value for the left hand side and then the right hand side to confirm your answer is correct. Now in the next video, we'll be looking at applications of linear equation. We'll be looking at word problems involving linear equations and how to solve them. So I'll see you in that video shortly. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at the part 1 of the application of linear equations. So without further delay, let's begin. So let's start with an example. So we have here the largest angle of a triangle is 6 times as big as the smallest. The third angle is 75 degrees. We have to write A, this information in the form of an equation for A, the size in degrees of the smallest angle. And then II, solve the equation and find the sizes of the 3 angles. Very good. Now this, like I said, is an application of linear equations. We need to understand what the question is saying, make it into a formulation and derive our equation from it, solve the equation and find the value of A or all the angles that the question is demanding for. So we have here the largest angle of a triangle is 6 times as big as the smallest. The third angle is 75. Now the I aspect is saying write this information in the form of an equation for A. the size in degrees of the smallest angle. So it means the smallest angle is equal to a degrees. Now if the smallest angle is a degrees, and we know that the largest angle in the triangle is 6 times as big as the smallest, it means that the biggest or the largest, let me use the correct word, the largest angle in this case is going to be 6a, because we've already been told in the question that the largest angle of the triangle is 6 times as big as the smallest. Now the third angle, we were given the value to be 75 degrees. Now if this statement holds true, it means we can go ahead and write the linear equation. So now the sum of the interior angles of a triangle add up to 180. So the sum of the interior angles, we'll be dealing with angles later on in the future. So sum of the interior angles of a triangle equals 180 degrees. So what it means is that if we add the smallest angle A plus the largest angle 6a plus the third angle 75 degrees, we are going to get a total of 180 degrees. So this becomes our equation. Now let's go ahead and solve this equation to find the value of a and then find all the angles. So we have a plus 6a plus 75 is equal to 180. We can group like terms here. We have a plus 6a is equal to then 180. We send the positive 75 to the other side, it becomes minus 75. So a plus 6a will give me 7a. This is equal to 180 minus 75 is going to give me 105. So I divide both sides by 7. My a is now equal to 107 divided by 105, divided by 7 will give me an angle of 15 degrees. So what this means is that my smallest angle is 15 degrees. The largest angle is 6 multiplied by 15, and that is equal to 6 multiplied by 15 will give me 90. And then the third angle, as we were already given, is 75. So if I add the total, 15 plus 90 plus 75 degrees will give me a total of 180 degrees, which is equal to the overall sum of the interior angles of a triangle. Alright, so let's proceed to look at the second example. We have Jack and Jackie are twins, and their brother Johnson is 2 years older than them. The total of their ages is 32. Write this information in the form of an equation for R, Johnson's age in years. What are the ages of the 3 brothers or the boys? Alright, so let's look at something. We're told that Jack and Jackie are twins. It means they are of the same age. Jack and Jackie are twins. It means they are of the same age. And their brother Johnson is 2 years older than them. We're told that the total of their ages is 32. We have to write this information in the form of an equation for R, Johnson's age. So we're told that Johnson's age should be represented by R. So let Johnson's age be equal to R. Now if Johnson's age is R, then it means for either Jack or Jackie, one of them, since Johnson is their brother and is 2 years older than them, Jack will be R minus 2 years old. Jackie will also be R minus 2 years old. So if we add this plus this plus r, it should give us 32. Now remember, we are saying Jack and Jackie are twins, so it means 2 times their age. Okay, so we can rewrite Jack and Jackie's age as 2 into bracket r minus 2. This is for Jack and Jackie. So if this holds true, it means that our equation will be equal to twice the age of Jack and Jackie, which is r minus 2, plus the age of Johnson is equal to 32. Since they are twins, we multiply their value by 2. Okay, or we can just add them, which will give us 2r minus 4. Either way, we can either add or multiply it by 2. Either way is correct. So 2 multiplied by r will give us 2r. 2 multiplied by negative 2 will give us negative 4, plus r is equal to 32. Now 2r plus r will give us 3r is equal to 32, plus negative 4 will come here, it becomes positive, so plus 4. So we have 3r is equal to 36. So 3r is equal to 36. We divide both sides by 3. Our r will be equal to 12. Now that we found the value of r, which is Johnson's age, it means that Johnson's age is 12. Now Jack is 12 minus 2, which is 10 years. Jackie is also the same, so 12 minus 2, which is also 10. Now if we add their total age, 12 plus 10 is 22, plus another 10 is 32 years, which is the total of their age given to us in the question. So what are the ages of the 3 boys? Johnson is 12 years old, Jack is 10 years old, and Jackie is also 10 years old. Alright, so let's have a look at one final example. The length d in meters of a rectangular field is 40 meters greater than the width. The perimeter of the field is 400 meters. We have to write this information in the form of an equation for d, and solve the equation and find the area of the field. Now there is a lot going on in this question. First, we're told that the perimeter of the field is 400. So let me write that down first. Perimeter is 400 meters. Okay, then we were told to solve the equation and find the area of the field. Now we need to find area. What is area? Now we're told that the field is rectangular. All right, another trouble. Rectangular, or a rectangle. So what is the perimeter of a rectangle? What is the area of a rectangle? We'll be looking at that. All right, so let's do the deductions. They said the length d in meters of a rectangular field is 40 meters greater than the width. Now it means the length is equal to the length d is equal to d. Okay, so the length is equal to d. Let me cancel this. The width of the rectangular field, because the length is greater than the width 40 meters, it means that to get the width we have to subtract 40 from the length to get a width. So this becomes the length of the width, d minus 40. We already have the perimeter, and then we don't know what the length and the width is. So until we find that, we can solve for the area. Now what is the perimeter of a rectangle? The perimeter of a rectangle is 2L plus 2W, where the L stands for the length, the W stands for the width. So the perimeter already we were told is 400, is equal to 2. The L in this case, which is the length, is d, plus 2. The width, which is the W over here, is d minus 40. So we have d minus 40. So this becomes our equation. So from here we can proceed to solve the problem. So we have 400 is equal to 2d plus 2 multiplied by d will give us 2d minus 2 multiplied by 40 will give us 80. This implies that 400, we can send the negative 80 to the other side of the equal to sign, or to the left hand side. It becomes positive, so plus 80 is equal to 2d plus 2d will give us 4d. So 400 plus 80 is equal to 480 equals 4d. So we divide both sides by 4, and then the value for d, which is the length of the rectangular field, will be equal to 120 meters. So it means that our length for this rectangular field is 120 meters. Our width will be equal to 120 minus 40, and that is equal to 80 meters. Now that we have the length and then the width, we have to find the area of the field, the area. Now the area of a rectangle or a rectangular field will be the product of the length and the width. That is equal to 120 for the length multiplied by 80 for the width. So 120 multiplied by 80 will give me 9,600 meters square as the area of this rectangular field. So thank you so much for watching. This is how we solve some applications of linear equations. This is how there's a problem can be framed on an application of linear equation. You need to look through the question, derive an expression in a linear way, solve it and find the value, and then proceed with whatever the question may demand. Hello and welcome to my science tutorials. In today's video, we want to look at the application of linear equations part 2. So without further ado, let's begin. So let's start with an example. Joe buys 18 kilograms of potatoes. Some of these are old potatoes at 22 cents per kilogram. The rest are new ones at 36 cents per kilogram. Denoting the mass of old potatoes he buys by m kilogram, write down an expression for the total cost of Joe's potatoes. II. Joe pays with a $5 note and receives 20 cents change. What mass of the new potatoes does he buy? Alright, so let's go ahead and solve this example. Alright, so we're told that Joe buys 18 kilograms of potatoes. That's the total mass of the potato that he bought. So let's write that the total mass equals 18 kilograms. Now we're told that some of these potatoes are old and they were sold at 22 cents per kilogram, and then the new ones at 36 cents per kilogram. We were also told to denote the old potatoes by m kilograms. So it means old potatoes in terms of mass is equal to m kilogram. So it means the price of old potatoes, let me make it OP, will be equal to 22 cents multiplied by the mass, because one mass, okay, which is 1 kilogram, is equal to m kilogram. All right, now let's look at the new potatoes. So the new potatoes will be equal to, since the total number of potatoes he bought is equal to 18 kilograms, and then the old ones are m. If we subtract m from 18, we get the mass of the new potatoes in kilogram. And so the price of the new potato will be equal to 36 cents multiplied by 18 minus m, and that will give us the price of the new potatoes. Now we're told that he paid $4 and he received 20 cents. That means the price of the total mass of the potatoes that he bought will be equal to 480 cents. Plus $5, that is 500 cents, and minus 20 cents, that will give us 480 cents. So this becomes the price of the 18 kilogram of potatoes that he bought. Now let's look at the equation. So our total cost over here will be equal to the sum of the old potatoes, which is the price, so it becomes 22m, plus the sum of the new potatoes, that will be 36, multiplied by 18 minus m. Okay, now we know that our total cost is 480 cents, that is equal to 22m plus 36 into bracket 18 minus m. Alright, so now we have an equation. So the first expression, this is the solution for I, total cost. This is the solution. So we have 480 is equal to 22m plus 36 into bracket 18 minus m. This becomes the equation denoting the mass of the potato, both old and new, and then the price. Alright, so let's go ahead and solve this equation and get our answer. So if we continue, we have 480 is equal to 22m. Then we expand the bracket over here. 36 multiplied by 18, that will give us 648 minus 36 multiplied by m will give us 36m. Alright, so from here we can go ahead and do our grouping of items. So we have 36 here, we have 22 here. Let me bring the m to the other side of the equal to sign. So I'll have 36m minus 22m to be equal to 648 minus 480. Alright, so 36m minus 22m will give me 14m is equal to 648 minus 480 will give me 168. So I divide both sides by 14. The value of m will be equal to 168 on 14 will give me 12, and that is in kilogram. Okay, so it means the mass m, which is the mass of the old potato, is 12 kilogram. Now if the mass of the old potato, so it means old potato is equal to 12 kilogram, then it means the new potatoes will be equal to 18 minus 12, and that will give me 6 kilogram over here. Now let's look at II. Joe pays with $5 note and receives 20 cents. What mass of the new potatoes does he buy? Okay, so we can already see that after calculating for our mass of old potatoes, and we subtract that from the total mass that we have, which is 18, we've obtained the mass of the new potato, that is equal to what? 6 kilograms. So this becomes our II. So the total mass of the new potatoes that he bought is 6 kilograms. Alright, let's proceed to look at one more example. We have in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. We have to write this information in the form of an equation involving Benjamin's present age, and we have to calculate how old Benjamin is right now. Right, so let's look at something. Now we're told that in 18 years time, Benjamin will be 5 times as old as he was 2 years ago. Okay, so 2 years ago, Benjamin will be, since we are to represent Benjamin's age with A, it means 2 years ago Benjamin was A minus 2 years. This was his year 2 years ago. Now we're told that 5 times as old as he was 2 years ago means that will be 5 multiplied by A minus 2. Okay, now in 18 years time, Benjamin will be, in 18 years time, if Benjamin's current age is A, in 18 years time Benjamin will be 18 plus A. Okay, Now that we've made these deductions from the equation that the question that we're given, let's proceed to see how we can write this information. So in 18 years time, which is 18 plus a, Benjamin will be 5 times as old as he was 2 years ago. So Benjamin will be equal to 5 times as old as he was 2 years ago. So this is as old as he was 2 years ago, 5 times as old as he was 2 years ago. So this becomes our equation for us to solve. Alright, so let's solve this equation and find Benjamin's current age. Alright, so we have 18 plus a is equal to, let's expand this bracket, 5 multiplied by a will give us 5a, 5 multiplied by negative 2 will give us negative 10. So I will maintain the 18 here and bring the negative 10 to the other side of the equal to sign. It becomes plus 10 is equal to 5a. Then I send this a to the other side of the equal to sign. It becomes a. So I have 28 is equal to 4a. Now 28 is equal to 4a. To make a the subject, I divide both sides by 4. So my a is now equal to 28 divided by 4 will give me 7 years of age. So it means Benjamin is 7 years right now. So if Benjamin is 7 years right now, it means in 18 years time, Benjamin will be 18 plus 7, and that will be equal to 18 plus 7. This will give us 25 years. So in 18 years time, Benjamin will be 25 years old. And let's see whether that is 5 times as old as he was 2 years ago. So that will be 5 into bracket 7 minus 2, and this is equal to 5. 7 minus 2 will give me 5, and this is equal to 25. So we can see that the right hand side of the equation, this side, and then the left hand side of the equation, this side, are all the same, and therefore it means that our answer is correct. So thank you so much for watching the part 2 of the applications involving linear equations. Now I will see you in the next video where we'll be talking about change of subject. So thank you once again, and bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn about the change of subject. Right, so without further ado, let's begin. So one of the most frequent things we do in mathematics or in science is always to find an unknown variable, or to make an unknown variable or quantity the subject. You get to do this when you are dealing with formulas and you have to find another parameter that is not the subject of the equation or of the formula. So for instance, let's say we have a is equal to bx plus cy cubed. Let's say this hypothetical equation, and we've been asked to find the value of b. In most cases, it is easier for us to find b if we make b the subject. If we make b the subject and then substitute the value of x, c, y, and then a if they are given, we do the substitution and we get our answer easy. So for us to make b the subject, it means we have to bring b to where the current a is over here, or we equate every other parameter or every other variable to what we are to make the subject, that is b in this case. So if we do that and we rewrite this equation to make b is equal to maybe a plus cy cube or something like that, this becomes our subject, and that is what we want to look at. We want to look at how to make a variable the subject in today's video. Right, so let's start with a typical example. So assuming we have a is equal to 1 over 2 a plus b multiplied by h, and over here we have to make small a the subject, so make a the subject. Alright, so how do we make small a the subject? Now if you look at this particular example, you realize that we have a is equal to half multiplied by a plus b multiplied by h. They are all multiplying each other together. just as one term. Okay, they are not different from each other, they are just one term. Everything is multiplying each other together. So in this particular case, the first thing we need to do is to get rid of the fraction that we have over here to have the equation in a more linear way. After that, we try to isolate a and make a stand alone, and then we make it the subject. So the first thing I do is I multiply through by the LCM. So I have a is equal to half multiplied by a plus b multiplied by 8. So I multiply through by 2. Okay, the 2 here becomes the LCM, so I use 2 to multiply through. So I have 2 multiplied by a will be equal to 2 multiplied by half into bracket a plus b h. So 2 multiplied by a will give me 2a is equal to, this will cancel this, so I'm only left with a plus b h. Okay, so from here, the next thing I can do, okay, is to, I can see I have a plus b multiplied by h. There is h here, we don't want h to be there, we want a plus b to stand alone, and after that you can make a to stand alone. So the first thing I do over here is I divide through by h. So this cancels this, so I have 2a on h is equal to a plus b. Now that I have this alone, I cannot make a the subject by maintaining the a here and bringing the b to the other side of the equal to sign. So if I do that, I have 2a on h. Then if I send the b to the other side of the equal to sign, it becomes minus, so minus b is equal to a. So therefore, it means that if I make my small a the subject, I'm going to get the expression 2a on h minus b. This is h. So this becomes my answer for the expression I'm supposed to make the subject. Alright, so what if we have another example? Let's look at another example. So we are to make t the subject in the simple interest formula below. So make t the subject in the simple interest formula. Interest is equal to principal multiplied by the rate multiplied by the time, all on 100. Right, so this is the formula we use to calculate simple interest. If you go and borrow a money, which is your principal, at a particular rate over a duration of time, this is the formula that we use to calculate the interest that will be added onto your principal for you to pay. Now we've been asked to make t the subject over here. Alright, so the first thing we do over here is to multiply through by 100, since we have a fraction over here. So we use 100 to multiply through. So we have 100 multiplied by interest is equal to principal multiplied by the rate by the time on 100 multiplied by 100 as well. Since this is one term, another term, we multiply both terms by 100. So this gives me 100i is equal to, this cancels this, principal multiplied by rate multiplied by time. Alright, so because principal, rate, and time are multiplying each other, and I want the time to stand alone, I divide through by principal and rate. So the time is now equal to 100 multiplied by the interest on principal multiplied by the rate. So that becomes the subject. After we make t the subject, this becomes the expression that we get for our answer. Alright, so let's make x the subject in the formula given below. So make s the subject in the formula. V is equal to w root of a squared minus x squared. All right, so we have the expression v is equal to w the root of a squared minus x squared. All right, so we are to make x the subject, and we can see that the x is embedded in a root sign. So the first thing we need to do is to get rid of the root sign. We do that by squaring. Okay, so we square both sides of the equation, So we have v squared is equal to w the root of a squared minus x squared squared. Now this will give us v squared is equal to, these are w and the content in the root sign are multiplying each other. So if we square all of them, we will have w squared, then the square root will cancel this, so it becomes a squared minus x squared over here. Right, so now that we've gotten rid of the root sign, the next thing we need to do is to make sure that our x term is standing alone. We can do that by, first of all, dividing both sides by w squared. So this cancels this. So it means we have v squared on w squared is equal to a squared minus x squared. Right, so from here, let me get some space. Okay, so from here, the next thing we need to do is to rearrange the equation to make s standalone, s squared standalone. So I'm going to bring s squared, let me maintain s squared here. So I have v squared over w squared. Then I send the a to the other side of the equal to sign, becomes minus a squared is equal to negative x squared. So this is the expression that I have. So from here, all I need to do, okay, is to first of all get rid of the negative over here because I don't want that. So I divide both sides by negative. So this cancels this. It means s squared will now be equal to v squared on w squared divided by negative will give me negative v squared on w squared. Negative a squared divided by negative 1 will give me positive a squared. So I can rewrite this equation as s squared is equal to a squared minus v squared on w squared. Alright, so from here, I need to make x stand alone. I can do that by finding the root of this equation. So I bring my root sign here, bring my root sign over here. So this cancels this. So my x as the subject now is now equal to the root of a squared minus v squared on w squared. So this becomes my answer if I make x the subject. Right, so let's proceed. So let's try the following question. So example number 1, we have to make m the subject, make m the subject in E is equal to mgh plus half mv squared. Then example number 2, make r the subject. We have to make r the subject in 1 over r is equal to 1 over r1 plus 1 over r2. This is the formula that we use to find the total resistance of resistors connected in parallel. Right, let's look at the last example. We have to make D the subject in u squared minus du plus fd is equal to 0. Alright, so let's write down our solution. Please, you can go ahead and try the questions, make the various M, R, and then D the subjects respectively, and then let's see our answer at the end. Right, so in the first one we have E is equal to mgh plus half mv squared. Alright, so we were asked to make M the subject. Before we do that, we can see we have a fraction here, so let's get rid of it. We do that by multiplying through by the denominator over here, which is 2. So we multiply each term, E, this term, and then this whole term as well by 2. So it becomes 2 multiplied by E is equal to 2 multiplied by mgh plus half mv squared multiplied by 2. So we have 2E is equal to 2mgh. These two will cancel this, so we have plus mv squared. Alright, so from here we can see that we have m common in here, so we can factor m out. So we have E, 2E is equal to, then I factor m out, I have m outside bracket into bracket 2gh plus v squared. So if I multiply the m by the content in the bracket over here, I get 2mgh. If I multiply m by the v square, I get mv squared. So from here I have 2e is equal to m 2gh plus v squared. I'm just repeating this. So from here I can divide both sides by 2gh plus v squared, 2gh plus v squared. This cancels the whole of this. So my m as the subject will give me the expression 2e all on 2gh plus v squared. So that becomes my answer for the first expression. Alright, so let's go ahead and find the solution for the second expression. So for the second expression, we were given the expression or the formula 1 over r is equal to 1 over r1 plus 1 over r2, and we're asked to make r the subject. Alright, so the first thing that we do in this case is we maintain this 1 over r is equal to, we have two fractions being added to each other, so we need to find the LCM for these two. The LCM in this case, because they are variables, they are not numbers, we multiply this and this to get the LCM. So we have r1 r2 as our LCM. Now r1 will go into r1 r2, so r1 will cancel r1, r1 will cancel r1, we are left with r2, so we have r2 here, plus r2 will cancel r2, we have r1 left, multiplied by 1 is still r1. So from here what we can do is we can reverse this, flip this and flip this to get our answer straight, or we cross multiply over here. So this r will multiply what is at the top, 1 will multiply what is at the bottom here. So we have r into bracket r2 plus r1 is equal to 1 multiplied by r1 r2. So from here we can divide both sides by r2 plus r1, r2 plus r1. So when we do that, we have our expression for r to be equal to r1 r2 on r2 plus r1. Okay, now let's look at the final expression that we're given. So we're given u squared minus du plus fd is equal to 0, and we're asked to make d the subject. Alright, so this is pretty much very easy, very straightforward. We're asked to make d the subject, but first of all let's group like terms, okay, so that we make this easy. So I'm going to maintain my u squared here to be equal to, then I send the other component of the equation that has dd attached to them, I'll send it to the other side of the equal to sign. So I send the negative du here, it becomes positive du. Then I send the positive fd, it becomes minus fd. Okay, so from here I still maintain my u squared is equal to, between du and fd, d is common, so I factor d out. So I have d outside bracket into bracket u minus f. Now I have my d multiplying the content in the bracket here, I have my u squared over here. So to make my d stand alone, I divide both sides by u minus f, u minus f. This cancels this. So my expression for making d the subject becomes u squared on u minus f. So this becomes my answer after making d the subject. So thank you so much for watching. I hope and believe that this brief video gave you the impression and how easy it is to make something or a variable the subject. It's just very easy. You just have to know how to maneuver your ways. When you have a fraction, you make sure you get rid of the fraction first. If you have square root sign, you make sure you get rid of the square root sign. If you have bracket, expand the bracket, rearrange your term. If you have your variable that you have to make the subject appearing more than once, make sure you factor it out to have it stand alone. Then you group the other components that are not attached to it to the other side of the equal to sign and make your variable that you've been asked to make the subject to make it the subject. So thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at quadratic factorization, how to get the factors of a quadratic equation. So without further delay, let's begin. Now, a quadratic equation is an equation of the form as squared plus bx plus c is equal to 0. So over here we can see that we have a, b, and c. These are known values. We have them as known values. We have values for them, and then the x term is what we don't know. Now, the difference between a quadratic equation and a linear equation is that a linear equation only has one variable, let's say x, and it's not raised to any specific power. So we can have 2x plus maybe 3 outside bracket 4 plus 2x is equal to maybe 18. This is a typical linear equation. This is a linear equation. But for a quadratic equation, it always has the x component, the variable, raised to a power more than 1. So we can have a over here in this instance is raised to the power 2, or we can have, let's say, as cubed plus bs squared plus cx plus d is equal to 0. This is also a quadratic equation. Now, for this particular type of equation, depending on the coefficient of the x term, that determines the number of answers or the root of the equation. In this particular example, because the x term is raised to the power 2, we have 2 answers that will satisfy this equation, and they become the root of the equation. Over here, we expect how many answers? We expect 3 answers for x that will satisfy this particular equation. So this is the format that a quadratic equation takes. Now, there are various ways of solving quadratic equation. You can either factorize them, use the quadratic formula, use the method of completing squares. Okay, so in this video we want to look at factorization, but not just how to factorize. We want to learn how to get the factors before we look at how to solve quadratic equations itself in the next video. So let's start by looking at an example. So we have to factorize xa plus xb plus ya plus yb. So we are only to get the factors over here. So if we look at this expression really well, we realize that we have xa plus xb plus ya plus yb. This is equal to, if we compare the first 2 terms that we have here, we can see that x is common for them, and then the third and then the last one, you can see that y is common for them. So we can factor these variables out. Now, if we factor s out between the first 2 expressions over here, if we factor s out, we will have a plus b inside the bracket. Now, plus between this and this, if we factor y out, we will have y outside bracket, then into bracket a plus b. Now, note that we are having a plus b repeating. Now, in this case, the a plus b is what we call the common factors. Okay, it becomes the common factor, so we don't need to write it 2 times. So from here, from the top over here, we write this and this together as one factor, so it becomes x plus y. Then we repeat one of the common factors, that is a plus b. So these two becomes our factors. So this is what we call the factors of this particular equation. These are the factors of this particular equation. Now let's have a real typical example of a quadratic expression and find the factors. So we have x squared plus 7x plus 12, and we have to find the factors of this equation. Now quadratic equations are often of the form ax squared plus bx plus c. Now to factor or to find the factors, the first thing we do is that we use the coefficient of the x squared term to multiply the c. So we have a multiplied by c, we get an answer. Now that answer that we get over here, we look for two numbers that if you multiply them you get the answer, but if you add or subtract you get the middle number over here, b. So let's look at that. So the example we have over here is x squared plus 7x plus 12 is this is the expression. So this is equal to, now the first thing we do is the coefficient of x squared term here is 1 multiplied by 12 is 12. So we have 12. You write that somewhere. Now which two numbers will you multiply to get 12? But if you add or subtract them you get 7. So if you think really well, you realize that 3 and 4 will do that. So if you multiply 3 and 4 you get 12, which is the c term we have over here after we multiply a and c. But if you add these 3 and 4 you get 7, which is in the middle over here. So this becomes a suitable number. But we have 2 and 5. But if we multiply 2 and 5, even though if we add them it will give us 7, if we multiply them it will give us 10, which is not 12. So we will not go for this. This will not be considered as our possible factors. We only go for 3 and 7, because if you multiply them you get 12, and then if you add them you get 7. So we are going to use 3 and 4. So how do you write that? You maintain your x squared, then you write the 7x in the form of 3 and 4. So you do that by writing, you can write 3 or 4 first, either way doesn't matter. So I'm going to write, in this example I'm going to write 4x first. So 4x plus 3x plus 12. Now if you look at this expression and what is on the left hand side, there's no big difference. We have x squared, we have x squared, we have 7x, here we have 4x plus 3x, and if you add them you get 7x. Then we have the constant 12, and then we have 12 here. So we have done nothing to the equation. We just rearrange the equation in a much more easier way for it to factorize and get our factors. Alright, so from here the next thing we do is to factor out the common terms between these first two variables that we have over here. So between x squared and then 4x, x is common, so we factor x out. Then we have x plus 4 in the bracket over here, then plus between 3x plus 12, 3 and 12, the factor that is common between them is 3, so we factor it out. Then we have into bracket x plus 4. So if we multiply 3 by x to give us 3x, 3 by 4 to give us 12. Now we can see we have x plus 4, which I said is the common factor. So over here we just maintain one of it. So we write x plus 3, and then x plus 4. So x plus 3, x plus 4 becomes our common factors. And that is the solution after we factorize this equation. Now remember, we are not solving quadratic equation, so we don't want to find the value of x. We just want to find how to come up with the factors. That is what this tutorial is about today. Right, so let's have a look at another example. So we have to factorize. Let's factorize x squared minus 2x minus 24. Alright, so we have this expression. Like I said, the first thing we need to do is to multiply the coefficient of the x squared term over here and the constant term, which is c. So we have the coefficient of the x term here is 1. The coefficient of the constant is 24, negative 24. So 1 multiplied by negative 24 will give us negative 24. Okay. Now which two numbers can we multiply to get negative 24? But if we add or subtract them, we get negative 2 in the middle over here. Alright, so if you think at it very well, 6 and 4 can do this job for us. Now 6 multiplied by 4 will give us 24. But if you add 6 and 4, you are not going to get negative 2. So it means one of them has to be negative. So let's negate the 6. Now negative 6 multiplied by 4 will give us negative 24, which is what we want. And then negative 6 plus 4 will give us negative 2. That is very good. So it means our factors, our potential factors is negative 6 and 4. So we are going to use them. So we still write our x squared. Over here, instead of writing negative 2x, we are going to write negative 6x plus 4x. Then we bring the constant minus 24. Okay, so from here we can go ahead and factor out x. So if I factor out x here, I'll have x outside, then into bracket x minus 6 plus between 4x and negative 24, 4 is common. So I factor out 4, then I have into bracket x minus 6 over here. So I can see my common factors. So I will now bring x plus this 4 and then x minus 6. So these guys becomes my common factors. Alright, so let's go ahead and look at another example. So we have to factorize the expression x squared minus 20x plus 100. As usual, I use the coefficient of the x squared term, which is 1 over here, to multiply the c, that is 100. So I have positive 100. Now, which two numbers can I multiply to get 100? But if I add or I subtract them, I get negative 20. Right, if you look at it very well, those two numbers are going to be 10, 10. So 10 multiplied by 10 will give me 100. But 10 plus 10 will give me a positive 20, not negative 20. But what if I use negative 10 multiplied by negative 10? Negative 10 multiplied by negative 10 will give me positive 100, which is true. And then negative 10 plus negative 10 will give me negative 20. So it means that negative 10 and negative 10 will do the work for me in this case. So I rewrite the expression as x squared minus 10x minus another 10x plus 100. So this is equal to, from here I can factor out my x. So I bring x outside. I have x minus 10 over here. Then minus over here I have between 10x plus 100, 10 is common, so I factor out 10. Then I write into bracket x minus 10. So negative 10 multiplied by x will give me negative 10x. Negative 10 multiplied by negative 10 will give me a positive 100. So from here, I can now rewrite my expression as x minus 10, which is this x minus this 10. And then I maintain one of the common factors, which is x minus 10. Now, for this particular example, you can see that we have x minus 10 occurring twice. So we can rewrite this as x minus 10 all squared. And this becomes our factors for factorizing this expression. Alright, let's look at one final example. So we have to factorize the expression x squared minus 49. Okay, so we have x squared minus 49. Now, mind you, if you look at this, we said that quadratic equation is of the form ax squared plus bx plus c. Now, if you compare this with this equation that we have over here, you realize that we don't have an x term over here. If that happens, if you have an expression where you don't have an x term, it means the coefficient is 0. So 0 multiplied by x will give you 0, and that is how come it has not been written. So this whole expression can be rewritten as x squared plus 0x minus 49. Okay, so from here I can now go ahead and do my usual. So the coefficient of x squared term here is 1 again. So I use that 1 to multiply negative 49. I get negative 49. So which two numbers will I multiply to get 49? Negative 49. But if I add or subtract them, I get 0. So it happens that 7 will do the job for us. So if I multiply -7 and +7, I get -49, but if I add them, I get 0. So I'm going to use that. So I have x squared, then I write -7x plus 7x minus 49. So the -7x plus 7x will give us the 0 over here. So we've not done anything to the equation. So now that I have it in this form, I can factor out my x. So if I factor x out here, I have x minus 7 here, plus between this and this, 7 is common, so I factor out 7, then into bracket x minus 7. So I can have here x and then +7, so that becomes x plus 7. Then I have x minus 7 here, so x minus 7 over here as my final expression. So after factorizing this equation, these are the factors that you get as the true root for this particular expression. So thank you so much for watching. This is how we find the factors of a quadratic equation. Now that we know how to find the factors, we will proceed with the next tutorial and we'll look at how to solve quadratic equations themselves, how we use this knowledge that we've obtained here to obtain the factors and go ahead and find the value of x in a particular quadratic equation, where we'll be using the method of factorization. So thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at solving quadratic equation by the method of factorization. So let's begin by looking at an example. So assuming we have x squared minus 40x minus 6000 is equal to 0. How do we go around solving this particular quadratic equation to get the roots of this equation? Alright, so the first thing we do is, normally quadratic equation is of the form ax squared plus bx plus c, where c is the constant. Now for us to rewrite this equation in a much more easier way to factorize, we first of all use the coefficient of the x squared term to multiply the c term. The result that we get, we try to find two numbers that we can either add or subtract to get the middle term over here, which is b. So let's look at that. If we multiply 1 by -6000, it's going to give us -6000. Now, which two numbers can we add or subtract to get -40? But if we multiply them, we get -6000. Alright, if we look at -100 and 60, that will do the job. -100 multiplied by 60 will give us -6000, which is what we get after multiplying the coefficient of x squared by -6000. And then if we add these two, we are going to get -40, which is in the middle, and that is what we want. So we can rewrite this whole equation as x squared minus 100x plus 60x minus 6000 is equal to 0. So if you look at this, we haven't done anything to the top equation. It's just that we've rewritten it in a much more easier way for us to factorize and get the roots of this equation. Alright, so between this term and then this term, we realize that there is x common, so we can factor out x. So if we do that, we have x outside, x minus 100 here. So if we expand this bracket back, we'll get what we have at the top here. Then plus, between this and this, we can say that 60 is common, so we factor out 60 into bracket x minus 100 here will give us the 6000 we have at the top over here. So we can see x minus 100, x minus 100, that becomes our common factor. So we only write one of it. So x plus 60, we are going to write this as 1. So x plus 60 as one of the factors, and then x minus 100 as another factor. So from here we equate each of these two factors to 0 to get our answer. So we have x plus 60 equals 0, or x minus 100 is equal to 0. So from here we have x is equal to -60, or x is equal to a positive 100 as our answer. Now this x is equal to 60 and x is equal to 100 are what we are calling the roots of the equation. That is, they are the values of x that satisfy this particular equation. So if we substitute x equals -60 back into this equation, we are going to get 0, and if we substitute s equals 100 into this equation, we are still going to get 0 as our answer. Right, so let's proceed to look at another example. Now this is a particularly interesting example. We are to solve x power 4 minus 13x squared plus 36 is equal to 0. Now wait, this is not what we signed up for. We are here to solve quadratic equations raised to the power 2. How come we have quadratic equation raised to the power 4? This is going to be difficult. Now there is an easier way for you to solve this without having to go through any hassle, and that is what we are going to do. So we just need to rewrite this equation in a way that we can have s squared term to be represented by another variable, and then we solve it and get our answer. By that I mean I can rewrite x power 4 as x squared squared, and that still give me x power 4. Okay, so I've not done anything to the equation. Then I repeat the remaining terms here, plus 36 is equal to 0. So I've not done anything to the equation. I've just rewritten x power 4 as x squared squared. Right now from here I can say let x squared be equal to y. So it means wherever I see x squared, let me replace that by y. So over here I'm going to have y with a square here at the top minus 13, then this x squared become y plus 36 is equal to 0. Now this is looking like our normal easy quadratic equation that we can factorize. So we go ahead to factorize this and get an answer. So we multiply the coefficient of the y square here, which is 1, by 36. That will still give us 36. Now which two numbers can we multiply to get 36? But if we add them, we get negative 13. So negative 4 and negative 9. If we multiply these two, we get positive 36, but we add them, we get negative 13. So we are going to write this as y squared minus 4y minus 9y. It doesn't matter whether you write the 9y or the 4y first, it doesn't matter because you're still going to get the same thing. Then plus 36 is equal to 0. So from here I can go ahead and factor out y over here. So I factor out y, I have y into bracket, y minus 4 over here. So y multiplied by y will give me y squared, y multiplied by 4 will give me negative y over here. Alright, so over here I have minus, between 9 and 36, 9 is common, so I factor out 9, then into bracket y minus 4 is equal to 0. So I can now write this and this. So I have y minus 9, y minus 4 is equal to 0. Right, so from here I can proceed to have y minus 9 is equal to 0, or y minus 4 is equal to 0. So let me erase these guys so that they don't confuse us. Okay, so from here it means my y is equal to positive 9, or my y is equal to positive 4. But now remember, we were not asked to find y, we were told to find x. We decided to introduce another variable we are calling y. So we need to bring that condition back. But we said that s squared is equal to y, which means s squared is equal to the 9 over here. So to find x, we take the square root of this. So we remember to introduce your plus or minus, because whether positive or negative, you're still going to get the same answer. So our x is equal to plus or minus 3 over here. So whether it's positive 3 or negative 3, if you square that, you're going to get 9. Alright, so this is our answer for the first option. The second one is, we are still going to write y squared is equal, s squared is equal to y, then s squared is equal to 4. Okay, so from here we take the root of both sides, so we are going to have s is equal to plus or minus the root of 4, and that will give us s is equal to plus or minus 2. Okay, so it means whether you square positive 2 or you square negative 2, you are going to get 4. So our answer now, the values of x is equal to, so s is either equal to negative 3, negative 2, positive 2, or positive 3. So these are the 4 values that will make this entire equation equal to 0. So you can see that the x term is raised to the power 4, and then we have 4 answers at the end of finding the values of x. So if it were to be s squared term, just s squared, we are expecting 2 answers. If it's s cubed, we are expecting 3 answers. That is how quadratic equation works. If it is x power 4, we are expecting 4 answers for that particular equation. Alright, so let's go ahead and look at another example. So we have to find the real roots for the equation. So find the real roots of the equation x squared minus 2 is equal to 8 on x squared. Alright, so let's go ahead and try to find the root of this particular equation. So we have s squared minus 2 is equal to 8 on s squared. Alright, so from here, the first thing we need to do is to get rid of the denominator over here, because we want to have this in a linear way. Rearrange it to get a quadratic equation before we can proceed to solve. So I have s squared as the denominator over here. So if I multiply through by s squared, I can get rid of the s squared over here. So I multiply through by s squared. So if I do that, I'm going to have s squared multiplied by s squared minus 2 multiplied by s squared is equal to 8 on x squared multiplied by s squared. So s squared multiplied by s squared, that will give me x power 4 minus 2x squared is equal to this. We cancel this, so it's equal to 8. So I can rewrite this equation as x power 4 minus 2x squared minus 8 is equal to 0. Now I have this equation in a linear way, in a linear form. I cannot proceed to try and factorize this equation. Now, as usual, you can see over here that we have x power 4, and that is not what we want. This way it is a little bit complicated to solve it by factorizing, but there's an easier way to do it. That is to rewrite this as x power s squared minus 2s squared, just like we did in the previous example. Then I say let y be equal to x squared. So it means this whole equation becomes y squared minus 2y minus 8 is equal to 0. Now this way I can solve it much more easier without having to do any long division. So I have y squared minus 2y minus 8 is equal to 0. From here, I multiply the coefficient of the y squared term, which is 1 by 8. So it will give me negative 8. Now which two numbers will I multiply to get negative 8? But if I add them, I'll get negative 2. Alright, so if you look at it, 2 and 4 will do that, but one of them has to be negative. So negative 4 and positive 2 will give you negative 8, but if you add them, you get negative 2. So I have here y squared minus 4y plus 2y minus 8 is equal to 0. So I can factor y out here. So I have y outside bracket, then y minus 4. Okay, if I expand this, it will give me what I have at the top here, plus between 2y and negative 8, 2 is common, so I factor out 2 into bracket, y minus 4 is equal to 0. So I have from here y plus 2, y minus 4 is equal to 0. So I have y plus 2 equals 0, or y minus 4 is equal to 0. So I have y is equal to either negative 2 or y is equal to positive 4 over here. Now remember, you introduce y, so you need to go back and do the substitution. But you said that s squared is equal to y, so s squared is equal to negative 2. So s will be equal to the root of negative 2. Now the root of negative 2 will give us complex numbers. So this has no real solution, so we have no real solution for this particular first term. But the second term, x squared is equal to 4. So if we take the root of 4, you're going to have, this is plus or minus the root of 4. X will be equal to plus or minus 2. So for this particular equation, the real roots, instead of having 4 answers, the real roots, that is the real numbers that can make this equation to be equal to 0, is plus or minus 2. This is our answer as we've obtained from this side. Alright, so let's have a look at one final example. Alright, so we are to find the real root of the equation. So find the real roots of this equation. So we have 3x squared minus 5x plus 2 is equal to 0. Now this is very easy. You can try your hands on it by pausing the video, try and solve it, and let's go. Alright, so the first thing I always do, like I said, is to use the coefficient of the x squared term to multiply the constant. So 3 multiplied by 2 will give me positive 6. Now, which two numbers will I multiply to get 6? But if I add or subtract them, I'll get negative 5. Alright, so 3 and 2. Negative 3, negative 2, if you multiply them, you get 6. But if you add them, you get negative 5. So we'll go with that. So you have 3x squared minus 3x minus 2x minus 3x minus 2x will give you minus 5s plus 2 is equal to 0. So from here, I can go ahead and factorize. So over here, 3x is common. So I factor out 3x into bracket x minus 1. Then over here, 2 is common. So I minus 2 into bracket x minus 1 is equal to 0. So negative 2 multiplied by x will give you negative 2x. Negative 2 multiplied by negative 1 will give me positive 2. So I have here 3x minus 2. Then I have x minus 1 is equal to 0. So from here I have 3x minus 2 is equal to 0, or x minus 1 is equal to 0. So from here I have 3s is equal to 2. So I divide both sides by 3 to make my x stand alone. So my x will be equal to 2 on 3. Or from here I move negative 1 to the other side of the equal to sign, it becomes positive 1. So my solution for this particular equation is s is either equal to 2 on 3 or positive 1. This becomes my real roots for this particular equation. So thank you so much for watching. In the next video, we'll be looking at how to factorize complex quadratic equation raised to the power x raised to the power 4, power 6, power 5. You're going to look at them and see how we solve them in a much more easier way rather than using the complex method that is available. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn how to factorize quadratic equations with higher powers very easily. So let's begin. Now, it is very easy for you to simplify quadratic equations raised to the power 2. For instance, a typical example like 3x squared minus 5x plus 2 is equal to 0. It is very easy for you to factorize this quadratic equation. But what if we have the x raised to the power 4 or power 5 or power 6? Where we will be expecting, from this case, we are expecting 4 answers for x, here 5 answers, and probably here 6 answers for x. How do you go around solving this type of quadratic equations much more easily without doing any complicated calculations? So that is the essence of today's video. We want to look at how to use some easy method to solve quadratic equations having this x raised to higher powers. So let's solve the following equations. So we have to solve the following equations. So we have x raised to the power 4 minus 5x squared plus 4 is equal to 0. We have x raised to the power 4 minus 10x squared plus 9 equals 0. Then we have I. We have 9x power 4 minus 13x squared plus 4 equals 0. Then we have IV, our last expression, x power 6 minus 9x cubed plus 8 is equal to 0. Alright, so let's go ahead and tackle these problems to see how we solve them much more easier. Alright, so let's find out the solution for the first example. So in the first instance, we have x power 4 minus 5x squared plus 4 is equal to 0. Now, in this type of equation, what we need to do, we need to use some substitution method. But before we do the substitution method, we need to rewrite the equation in a way that we can get it as the normal quadratic equation having x squared term. So to do that, we rewrite x power 4 as x squared. This will still give us x power 4. Then minus 5x squared plus 4 is equal to 0. Now from here we say let y be equal to x squared. So it means wherever we see x squared, let's put y over there. So this whole equation becomes y. From here we substitute y in place of x squared here. So we have y. Then this power 2 here will come here 2. Then minus 5. The x squared here becomes y plus 4 is equal to 0. Now this looks like a quadratic equation, or this is a quadratic equation raised to the power 2. So we can easily solve this and get our answer. Alright. So let's continue. So from here, we can go ahead and factorize to get our answer for y. Now, the first thing we do is we take the coefficient of the y squared term here and use it to multiply 4. So 1 multiplied by 4 will give us 4. Now, which two numbers can we multiply to get 4? But if we add or subtract, we get negative 5. Now, negative 4 and negative 1, if we multiply them, we get positive 4. But we add them, we get negative 5. So we use them. So we have y squared minus 4y minus y plus 4 is equal to 0. Okay, so from here we can go ahead and factor out our y. So we have y here, then y minus 4 over here. Then between this and this, we have negative 1 common. So we have negative 1 into bracket y minus 4 is equal to 0. So negative 1 multiplied by y will give me negative y. Negative y multiplied by negative 4 will give me positive 4. So I can now write my y minus this one over here, and then I repeat one of the common factors, y minus 4 is equal to 0. So from here, my y is either equal to positive 1 or my y is equal to positive 4. Now remember, you made a statement that let y be equal to x squared. We did not have that given to us in the question. We introduced it ourselves. So it means that our y is not our answer. We need to substitute it back into this equation and get the value for x. So we say that now this becomes x squared is equal to 1 or x squared is equal to 4. So if x squared is equal to 1, to find x, we take the root of 1. So it becomes plus or minus root of 1. Or from here we have s is equal to plus or minus the root of 4. Okay, so x is equal to, the root of 1 is still 1. So we have plus or minus 1. Or plus or minus the root of 4 is 2. So s is equal to plus or minus 2 over here. So therefore it means that our roots for x are negative 1, negative 2, 1 and 2. So these are the values, or these are the real roots for this particular equation. So when you substitute any of these values into the original equation, you should get 0 as your answer. So this becomes our answer for the first expression, plus or minus 1, plus or minus 2. So based on this first example that we've done, you can go ahead and try your hands on the second example, the third, and then the last example to see the answers you get and compare them with mine after we are done solving. So you can pause the video and go ahead, attempt the second question, the third one, and then the last one using this explanation I just gave earlier. All right, so let's begin. So let's look at the second example. For the second example, we have x raised to the power 4 minus 10x squared plus 9 is equal to 0. Alright, so just like we did in the first instance, we rewrite x power 4 as x squared minus 10x squared plus 9 is equal to 0. So I can say let s squared be equal to y. So I do the substitution. I have here y squared now, because s squared now is now y. Then minus 10, s squared will now be y, plus 9 is equal to 0. So this becomes my new equation for me to solve. Okay, so the coefficient of my y squared term is 1. 1 multiplied by 9 will give me positive 9. Now, which two numbers will I multiply to get 9 but add to get 10? So 1 and 10 will do that job. 1 and 9 will do that job for us. So negative 1, negative 10. Sorry, negative 1, negative 9. If you multiply them, you get positive 9. But if you add them, you get negative 10. So we do that. So we have y squared minus y minus 9y plus 9 is equal to 0. So from here, we can factor out y over here. So we have y into bracket y minus 1 over here. Then we have minus 9 into bracket y minus 1 is equal to 0. So we have our common factors. So we bring this and this together. So we have y minus 9, y minus 1 is equal to 0. So if we equate this guy to the equal to 7, we have y is equal to positive 9 or y is equal to positive 1. But we said that y is equal to x squared. So it means that y, which is equal to 9, is equal to x squared. Implies that x squared is equal to 9, or y implies that 1 is equal to x squared. So from here, we can go ahead and find our x. So our x is now equal to, we take the root of 9. So we add plus or minus the root of 9. Or we have x is equal to, we take the root of 1 to get rid of the square here. This becomes plus or minus root of 1. So for the left hand side, we have the root of 9 will give us 3. So our answer here will become plus or minus 3. Or over here, x will be equal to plus or minus 1. So therefore, it means that our roots for this equation are plus or minus 1 or plus or minus 3. So that becomes our answer for the second expression. Alright, so let's try and go ahead and solve the third expression. So we have I, or Roman numeral 3, 9x power 4 minus 13x squared plus 4 is equal to 0. So this is just like the first two examples we've done. Very easy, the same way, and we are going to get our answer. So comment down your answer below before we reach the final answer that we have. All right, so for this equation, we still use the same method. So we have 9 into bracket s squared minus 13s squared plus 4 is equal to 0. I've just rewritten x power 4 as x squared. So from here, I can say let s squared be equal to y. You can use any variable apart from y. You can use z, you can use k, any variable at all. Alright, so it means that this becomes 9y squared minus 13y plus 4 is equal to 0. Alright, so now we need to factorize this equation. So we use the coefficient of the y squared term, which is 9, to multiply 4. So 9 multiplied by 4 will give me 36. Now, which two numbers can I multiply to get 36 but add to get negative 13? So if you look at it, 9 and 4 will do that for us, because negative 9 multiplied by negative 4 will give me positive 36, and if I add negative 9 and then negative 4, I will get negative 13. So we use that. So we have 9y squared minus 9y minus 4y plus 4 is equal to 0. So from here I can factor out 9y. So 9y outside bracket, then I have y minus 1, then over here I have minus 4, y minus 1 is equal to 0. So my expression will not be 9y minus 4, y minus 1 is equal to 0. So from here it means that 9y is equal to 4, or y is equal to 1, and then over here it means y is equal to 4 on 9. Alright, so this becomes the answer that we have for y over here. But we said that x squared is equal to y, so it means in the first instance x squared is equal to 4 on 9, or x squared is equal to 1. This means if we want to get rid of the square term, we bring the square root sign, this cancel this. So our x is now equal to plus or minus root of 4 on 9 will give me 2 on 3. Okay, because this is 2 squared, this is 3 squared, they cancel the root sign, so we have plus or minus 2 on 3, or x is equal to plus or minus 1, because if you take the root over here, this cancel this, root 1 is still 1, so our answer is plus or minus 2 on 3, or plus or minus 1. Alright, so let's have a look at the final expression that we have for this particular tutorial. So we are to solve x power 6 minus 9x cubed plus 8 is equal to 0. Now you can see that this is a little bit different from the first 3 examples that we've solved. This is raised to the power 6, but the application is still the same, nothing changes. We first of all rewrite this expression as s squared, but this time around raised to the power x cubed raised to the power 2. That is how we rewrite it, s cubed raised to the power 2. So this will still give us 6, then minus 9s cubed plus 8 is equal to 0. So from here I can say let y be equal to s cubed. So it means wherever I see s cubed, let me replace it with y. So I have here y squared minus 9y plus 8 is equal to 0. From here I can go ahead and factorize. So I use the coefficient of the y squared term to multiply the 8, which is the constant. So 1 multiplied by 8 will give me 8. So which two numbers will I multiply to get positive 8 but add to get negative 9? So negative 1, negative 8 will do that. Negative 1 multiplied by negative 8 will give me positive 8, but if I add them I get negative 9. So I have y squared minus y minus 8y plus 8 is equal to 0. So from here I can factor out y. So I have y into bracket y minus 1, then minus 8 into bracket y minus 1 is equal to 0. So I have my final expression as y minus 8, then y minus 1 is equal to 0. That means y minus 8 is equal to 0, or y minus 1 is equal to 0. So I have y to be equal to either positive 8 or y is equal to positive 1. But again, we said that let y be equal to s cubed. So it means that s cubed is equal to 8, or s cubed is equal to 1. Alright, so if that is the case, we can go ahead and solve this. So if s cubed is equal to this, we can take the cubic root of both sides. So we take the cubic root, this cancels this, so x is equal to the cubic root of 8 will give me 2. So 2 times 2 is 4 times 2 is 8, so the cubic root of 2 is 8. Or then we take the cubic root of 1, then the cubic root of 1 is still 1, so this is equal to 1. So for this expression there are only two answers, s is equal to 2 and then s is equal to 1. So these two answers will make this entire equation be equal to 0 if we do a substitution. So let's try that out. So if we place 1 in here, 1 power 6 is still 1, minus, if we place 1 here, it's still 1 multiplied by 9 is still 9. So 1 minus 9 will give us negative 8 plus positive 8 is equal to 0. So we see that it satisfies this equation. And if we substitute 2 as well, we are still going to get 0 as our answer. So thank you so much for watching. This is how we solve quadratic equation raised to higher powers much more easily, just by doing a simple substitution and then getting our answer. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at word problems involving quadratic equations. So without further delay, let's begin. So we want to start by looking at an example. We have the length of a rectangular field is 30 meters greater than its width, W, in meters. We have to write down an expression for the area, A, in meters squared, of the field in terms of W, II. The area of the field is 8,800 meters squared. We have to find its width and perimeter. Okay, so this is very easy, very simple to do. Let's look at our solution. So we're told that the length of a rectangular field is 30 meters greater than its width, W. So we have the width of the rectangular field being equal to W in meters, and then we were told that the length of the field, the length, is 30 meters greater than the width, so it should be 30 plus W. This should give us the length of the rectangular field. So we have to write down an expression for the area, that is for I. Now the area of a rectangle or a rectangular field equals the length multiplied by the width. So now that we know this, it means area is equal to our width, our length is 30 plus W, and our width is W. So therefore it means that our area, if we expand this bracket, we are going to get 30W plus W squared, and so this becomes the expression for our area. We have 30W plus W squared. Alright, now we have to find the area of the field. The area of the field is 8,800 meters squared. We have to find its width and the perimeter. So let's go ahead and do that. So we're told that area is equal to 8,800 meters squared, and we know that the expression for area that we had is equal to W squared plus 3 plus 30W. Okay, I just interchange the position of W squared and 30. So from here it means I have 8,800 is equal to W squared plus 30W. Now for me to be able to find W, I need to rewrite this whole equation to get my quadratic equation. So I send the 8,800 to the other side of the equal to sign. So I have W squared plus 30W minus 8,800 is equal to 0. So this becomes my equation that I need to factorize and get my answer. Now if I use the coefficient of the W squared term here, which is 1, to multiply negative 8,800, I get negative 8,800. Now which two numbers will I multiply to get negative 8,800? But if I add or subtract, I get the middle coefficient, which is 30 over here. Now apparently if you use 110 and 80, you can do that. So positive 110 and negative 80, if you multiply them, you get 8,800. That is negative 8,800. But if you add 110 and negative 80, you are going to get 30. So let's use that. So we have W squared plus 110W minus 80W minus 8800 is equal to 0. Right, so from here I can factor out W out. So if I do that, I have W inside bracket, then I have W plus 110, then I have over here minus between 80W and 8800. 80 is common, so I write my 80 into brackets. Then I have W plus 110 is equal to 0. So from here I can have W minus 80, then W plus 110 is equal to 0. So therefore it means that a W is equal to, if I send this to the other side of the equal to sign, it becomes positive 80 meters. If I send 110 outside, it becomes, or negative 110 meters. Now you realize that the width is either 80 or 110, but the width cannot be negative. Because the width cannot be negative, it means that our W over here is equal to 80 meters. So 80 becomes our answer for W. Now, we're also asked to find the perimeter of the field. Alright, so to get a perimeter, we need to first find the width, find the length before we can go ahead and find the perimeter. So from here, it means that 30 plus 80, okay, which is 30 plus the width, will give us a total of 110 meters as the length of the rectangular field. So from here we can go ahead and find our perimeter. Okay, so our perimeter is equal to, the perimeter of a rectangle is 2L plus 2W. So that means that we have 2 multiplied by our L, which we found is 110, plus 2W. The W is the width, which is 80 over here. So therefore it means that we have 2 multiplied by 110 will give us 220, plus 2 multiplied by 80 will give me 160. Okay, so if I add the two, I get 380 meters as the perimeter for this particular rectangular field. So this is how we solve this type of question to get the parameters that we're asked to find. All right, let's have a look at another example to further appreciate what we're doing. So we have a cylindrical thing of height h centimeters and radius r centimeters, has a surface area including its top and bottom a meters squared. We have to write down an expression a in terms of r, h, and pi. A tin of height 6 centimeters has the surface area of 54 pi centimeters squared. What is the radius of the tin? And then I. Another tin has the same diameter as the height. Its surface area is 150 pi centimeters squared. What is its radius? Alright, so let's go ahead and try our hands on this problem. So we're told that a cylindrical tin has a height h centimeters and radius r centimeters, and the surface area includes both the top and the bottom. So the I is demanding that we write an expression for the area in terms of the radius, the height, and pi. Okay, now the area of a cylindrical tin which has both the top and then the bottom there and not removed is 2 pi r squared plus 2 pi rh. So this is the expression for the area of a cylindrical tin having both the top and then the bottom covered. So this is the expression for I. Now the tin of height 6 centimeters. So we have height is equal to 6 centimeters. Then a surface area of 54 pi centimeters squared. We're asked to find the radius, which we do not know. Alright, so let's go ahead and look at that. Now we know that the area is equal to 2 pi r squared plus 2 pi rh. Okay, so we're given the area to be 54 pi is equal to, then this we have 2 pi r squared plus 2 pi r. The h is 6, so we can do that substitution. So we have 54 pi here is equal to 2 pi r squared plus 2 multiplied by 6 will give me 12 pi r. So I continue over here. So from here I can decide to factor out 2 pi because 2 pi is common over here. So I have 54 pi is equal to, if I factor out 2 pi over here, I'm going to have 2 pi outside, then into bracket r squared plus this will give me 6r. Okay, so it means if I expand this bracket, 2 pi multiplied by r will give me 2 pi r squared. 2 pi multiplied by 6r will give me 12 pi r. Okay, so from here I can divide both sides by 2 pi. So this cancels this. So 54 pi divided by 2 pi. Pi will cancel pi. 54 divided by 2 will give me 27. Is now equal to r squared plus 6r. So I rewrite this equation. I have r squared plus 6r minus 27 is equal to 0. Now we can see our quadratic equation that we need to factorize. So let's go ahead and factorize this quickly. I multiply the coefficient of the r squared term plus the constant. So 1 multiplied by negative 27 will give me negative 27. Now which two numbers can give me negative 27 if we multiply them, but if we add or subtract will give me a positive 6. So 9 and 3 will do that. 9 times 3, 9 multiplied by negative 3 will give us negative 27, but 9 plus negative 3 will give us positive 6. So let's use that. So we have r squared plus 9r minus 3r minus 27 is equal to 0. So from here I factor out r. I have r outside bracket into bracket r plus 9 here, then minus 3 here into bracket r plus 9 is equal to 0. So I now have my factors to be r minus 3, r plus 9 is equal to 0. And so if I send these guys to the other side of the equal to sign, okay, so I have, let me make some small space here. I have r minus 3 is equal to 0. So therefore r is equal to 3, or r plus 9 is equal to 0, and then r is equal to negative 9 over here. Now since the r we are finding, which is the radius, cannot be negative, it means that our r is 3 over here, which is supposed to be 3 centimeters. So the value for our radius in the II option is 3 centimeters. So the radius of the tin is 3 centimeters over here. Now let's go ahead and look at the II aspect of this question. So let me get rid of everything here. Okay, so III. They said another tin has the same diameter as the height. So we were told that the diameter is equal to the height in this case. Now its surface area, the area is equal to 150 pi centimeters squared. Now we're asked to find what the radius is. Alright, so now let's make some deductions over here. We were told that the diameter, which is I'm representing with D, is equal to the height, which is equal to h over here. I know that 2 times the radius will give me the diameter. So it means that 2r will give me the diameter, which is equal to the height. So it means that wherever I see height, I can replace it with what? 2r over here. So let's look at that. So our area, the expression for our area, we said is 2 pi r squared plus 2 pi r h. Now we have h over here, so I can replace it with 2r. So the expression for my area becomes area is equal to 2 pi r squared plus 2 pi r multiplied by 2r. So my area is now equal to 2 pi r squared plus, now 2 multiplied by 2 give me 4. Then I maintain the pi, r multiplied by r will give me r squared. Okay, now I can proceed to solve my answer. My area is 150 pi. So we have 150 pi is equal to 2 pi r squared plus 4 pi r squared. Okay, so from here I can decide to factor out 2 pi. So I do that. So I have 150 pi is equal to 2 pi outside bracket, then into bracket r squared plus, because I factored out 2 pi over here, I'll be left with 2r squared over here. So from here I divide both sides by 2 pi, this cancels this cancels this. 150 on 2 will give me 75 is equal to, over here I have r squared plus 2r squared, that will give me 3r squared. Okay, so from here I can divide both sides by 3, get rid of this, so r squared is equal to 75 on 3, that will give me 25. And to find my r is equal to plus or minus the root of 25, and then it means that my r is equal to plus or minus 5. So r is either positive 5 or r is negative 5, but we know that our answer cannot be negative since our radius is supposed to be positive, so it means that we are going to go for the positive value. So our r, which is our radius, is equal to 5 centimeters in this case. All right, let's go ahead and try one last example. Now we have, when the first n positive integers were added together, their sum is given by half n into bracket n plus 1. We have to demonstrate that this result holds for the case n is equal to 5, and find the value of n for which the sum is 105. What is the smallest value of n for which the sum exceeds 1,000? All right, so let's go ahead and look at how to answer this particular problem. So our solution: I. We are to demonstrate that the result holds true for the case n is equal to 5. Now, when n is equal to 5, it means the maximum value over here for the positive integers is 5. So the positive integer starts from 1. So we have 1, 2, 3, 4, 5. Now we're told that if they are added together, their sum is equal to the expression over here. So let's see whether that is true. If I decide to add all the expression over here, 1 plus 2 plus 3 plus 4 plus 5. So 1 plus 2 will give me 3, 3 plus 3 will give me 6, 6 plus 4 will give me 10, 10 plus 5 will give me 15. So I have 15. Now let's see if we use the expression which is half n into bracket n plus 1, we are still going to get a 15 over here. So our n we're told is 5, so we do the substitution: half into bracket 5 and into bracket 5 plus 1. So this is equal to half multiplied by 5 multiplied by over here is 6. So this is equal to, I can rearrange this as half multiplied by 6 multiplied by 5. So this gives me half of 6 is 3, then multiplied by the 5, and this is equal to 15. So over here I can say that I have 15 if I use the value n, which is equal to 5, and I substitute it into this expression, I get 15. Now if I use the manual way and I add them by myself, I also get 15 at the end over here. So it means that the expression half n into bracket n plus 1 holds true. It holds true for n is equal to 5 as required by the question over here. All right, so let's proceed to find the value of n for which the sum is 105. So I. So we have to find the value of n, we don't know, for which the sum is equal to 105. So we know that the sum of these n positive integers is equal to half n into bracket n plus 1. All right, so we're told that the sum is 105, then this is equal to half n into bracket n plus 1. Okay, so we have to find n. So the first thing we need to do over here is to get rid of this fraction. We can do that by multiplying both sides by 2. So 2 multiplied by 105 over here is equal to 2 multiplied by half n into bracket n plus 1 over here. So 2 multiplied by 205, that will give me 210 is equal to, this cancels this, so I have n into bracket n plus 1 over here. So I can now write 210 is equal to n multiplied by n will give me n squared plus n multiplied by 1 will give me n. So I can rearrange this equation to get my quadratic equation. So I have n squared plus n minus 210 is equal to 0. Alright, so from here all I need to do is to factorize this expression to get my answer. Now 1 multiplied by negative 210 will give me negative 210. Now which two numbers will I multiply to get negative 210 but add or subtract to get negative n over here, positive n, sorry. So if I look at it very well, 14 and 15 can help me. So positive 15 multiplied by negative 14 will give me negative 210, but positive 15 minus 14 will give me 1, which is the n over here. So let me use that. It means I have n squared plus 15n minus 14n minus 210 is equal to 0. So if you look at this, if I multiply 15 by 14, I get negative 210. But if I add this, I get just positive n. So it means I have not done anything at all to this equation above over here. So from here, I can go ahead and factorize this equation. So I factor out n over here. So I have n plus 15 here minus over here 14. Then into bracket, I have n plus 15 as well over here. So I can now say my n minus 14 over here, then n plus 15 is equal to 0. So it means I have n minus 14 is equal to 0, n plus 15 is equal to 0. So my n is either equal to 14 or my n is equal to negative 15. Now we know that n is a positive integer, so we are not expecting a negative integer as our answer. So therefore it means that the value of n for which the sum is 105 is n is equal to 14. Okay, so let's go ahead and try the last aspect of the question. So they said, what is the smallest value of n for which the sum exceeds 1,000? So this is going to be pretty interesting. So let's get some space and continue. Alright, so I. What is the smallest value? Now note, they are asking for the smallest value of n. Smallest value of n for which the sum, okay, exceeds, or the sum is greater than 1,000. So let's look at that. So we know that the sum is equal to a half n plus 1. Okay, now if we want the sum to be greater than 1,000, let's use 1,000 to get the value of n, then see the closest value of n that will be greater than 1,000. So to do that, we said 1,000 here is equal to half n into bracket n plus 1. As usual, I multiply both sides by 2 to get rid of the half I have over there. So I get this expression. So 2 multiplied by 1,000 will give me a 2,000 is equal to n into bracket n plus 1. So I have 2,000 is equal to n squared plus n, and this gives me n squared plus n minus a 2,000 is equal to 0. Now if you look at this expression, 1 multiplied by negative 2,000 will give me negative 2,000. But which two numbers will I multiply to get negative 2,000? But if I add them, I get a negative n. Apparently there's no number that can give us this particular answer. So we are going to use another method. Instead of factorizing, we'll use the quadratic equation. So the quadratic equation, n will be equal to minus b plus or minus the root of b squared minus 4ac all over 2a, where my a is equal to the coefficient of the n squared term, which is 1. The b is equal to the coefficient of the n term, which is also 1. And then the c, which is the constant, is the coefficient, is this value over here, the last value, so it's negative 2000. Alright, so let's do the substitution and see. So our n is equal to minus b will be minus 1 plus or minus the root of 1 squared minus 4 into bracket a is 1. So 1 multiplied by negative 2000 will still be negative 2000 here. Okay, all over 2, and a is still 1. So our n is equal to minus 1 plus or minus the root of this will give me 1 plus 8000 over here, all over 2. And so this is equal to n is equal to minus 1 plus or minus the root of 8001 all on 2. Okay, so from here I can go ahead and find the value of n. So let me grab my eraser and get some space over here. Okay, so from here I can decide to do two things. I have minus 1 plus the root of 8001 on 2, and that will give me, if I simplify this in my calculator, minus 1 plus the root of 8001 on 2 will give me 44.22, or minus 1 minus the root of 8001 on 2. If I simplify this expression, this is n2, let me make this n2, this is n1. If I simplify this expression in my calculator, it's going to give me negative 45.22. Now, from these two answers, we obviously know that we can go for the negative answer, and so our right answer in this case is 44.22. But now note, the question is asking what is the smallest value of n for which the sum exceeds 1000. Okay, and we are getting 44.22. So it means that the correct answer is supposed to be greater than 44. The next integer after 44 is going to be the right answer. Okay, so let's test that out. So if n is equal to 44, let's see what we are going to get. So if n is equal to 44, we are going to get the sum to be equal to a half multiplied by 44 multiplied by 44 plus 1, and this will give me 22 multiplied by 45, and this is equal to 990. So it means that n has to be greater than 44 as an integer. So let's test if n is equal to 45. Let's see that out. So the sum will be equal to a half multiplied by 45 multiplied by 45 plus 1, and this is equal to a half multiplied by 45 plus 1 is 46. Then I bring the 45 here. So this is equal to half of 46, that will give me 23, and 23 multiplied by 45 will give me a total of 1035. So 1035 is definitely greater than 1000, and so our correct answer is n is equal to 45 over here. So thank you so much for watching. This is some application or some word problem that involves the application of quadratic equation. Thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic equation by using the method of completing the square. Alright, so in our previous tutorial we did look at how to use the method of factorization to solve quadratic equations. Now, it's not always the case that you have an expression or a quadratic equation that you can easily factorize. Now, in the absence of you being able to factorize a quadratic equation, which other ways can you use to solve the quadratic equation? That's what we are about to look at. So the other ways, so first of all, we can use the method of factorization to solve a quadratic equation. But in case we cannot factorize the equation, what other way can we use to find the factors of the equation. So one of them we can use is what we call the graphical method, and this involves us drawing a graph and using the graph to find the values of x. Or another method is completing the square. That is what we'll be looking at in today's video. So completing the square, and this is a very easy, super easy method, but a lot of students find it very difficult. So I'll be taking my time to explain step by step everything you need to do. Once you follow them, you'll never get the method of completing the square wrong ever again. Alright, so the last way of solving a quadratic equation is by using what we call the quadratic formula. Okay, quadratic formula, or some people call it the almighty formula. But then this formula, you realize that it was derived from the quadratic expression using the method of completing the square, and we'll be looking at that in our next video. So we already look at how to solve quadratic equation by the method of factorization. Today we'll be looking at how to solve quadratic equation using the completing of squares, and then in our subsequent videos we'll be using the quadratic formula and hopefully the graphical method in the next subsequent tutorial. Right, so let's look at how to solve quadratic equations using the method of completing the square. Right, so we have the expression x squared minus 6x plus 2 is equal to 0, and we have to solve this expression by the method of completing the square. Now the first thing you need to do, and always make sure you remember this, the first thing you always have to do is to make sure that the coefficient of the x squared term over here is 1. Always make sure it is 1. So assuming I have 2x squared minus 6x plus 4 is equal to 0, always make sure you divide by 2, divide 2 by the coefficient of x to make sure x squared is standing alone. Always make sure that the coefficient of x squared term is 1 before you go ahead and try to solve any problem on the method of completing the square. So now that we have this problem and we don't need to do anything because the coefficient of the x squared term is already 1, let's look at the next thing we need to do. So we need to rearrange this equation. So we write x squared minus 6x, then we send the constant to the other side of the equal to sign, so it becomes minus 2. Okay, so the next thing we need to do after rearranging is we add to both sides, half square the coefficient of x, the coefficient of x. Alright, so let me explain using this example. So what it means by that is, first of all, what is the coefficient of x here? It means that is negative 6. So I find half of negative 6. Half of negative 6 will give me negative 3. Okay, so the expression is, or the sentence is saying half square. So now that I found the half, I need to square it. So negative 3 square is 9. So this is half squared. So I need to add it to both sides of the equation. So I have x squared minus 6x plus 9 is equal to negative 2 plus 9. Alright, now the reason why we need to make the coefficient of the x squared term 1 and add half square coefficient of x is because we want to get a perfect square on the left side of the equation. Now this is an expression that we call a perfect square. Perfect square in the sense that this, I can rewrite this as x minus 3 all squared. If I expand this expression, I'm going to get what I have at the top over here. So let's look at how it works. It's either you rewrite this as 3 squared, then you take the x, the 3 together and square it, or you identify that it's a perfect square and then you do it like that. So this is a perfect square. Let's look at that. So we have x minus 3 squared. So this is equal to x minus 3, x minus 3. So let me multiply, expand, and let's see whether it's correct. So we have x into bracket x minus 3, then minus 3 into bracket x minus 3. So x multiplied by x will give me x squared. This will give me negative 3x. This will give me another negative 3x, and this will give me positive 9. So this is equal to x squared minus 3x will give me minus 6x plus 9. So we can see that the expression x minus 3 squared is equal to this expression we have over here, which is the same that we have over here. So I can rewrite this whole expression as this in this sense because it is a perfect square. Alright, so from here I've rewritten this as a perfect square, and this is equal to negative 2 plus 9 will give me positive 7. Alright, so from here all I need to do is to make sure that I find the value of x. So I can do that by first of all getting rid of the square over here. So I find the root of both sides. So the root of x minus 3 squared is equal to, now if you are taking the root of any number, you add plus or minus, then the root of 7. So this will cancel this. So we have x minus 3 is equal to plus or minus the root of 7. So from here we can proceed to solve for the values of x. So let me get rid of this. Okay, so from here I rewrite my expression as x is equal to, I send the negative 3 to the other side of the equal to sign, it becomes positive 3 plus or minus the root of 7. So my x values will be x1 is equal to positive 3, then I take one of the signs plus root 7, or positive 3 minus root 7. Okay, so my x will be equal to positive 3 plus root 7 will give me 5.646, or positive 3 minus root 7 will give me 0.354. So these two values, s is equal to 0.354 or 5.646, becomes the root of this equation, or the answers that will make this equation equal to 0. Alright, so let's have a look at another equation so that we actually understand furthermore what we mean by the method of completing the square. So I have the expression x squared plus 5x plus 4 is equal to 0 using the completing the square method. Alright, so as always, the first thing I need to do is to make sure the coefficient of my x squared term is 1, and which is the case over here. The next step is for me to rearrange this equation by writing x squared plus 5x is equal to negative 4. I sent the positive 4 to the other side of the equal to sign. Alright, so over here I add half square coefficient of x, okay, that is, I add to both sides the coefficient of x. So that will be equal to half of 5 will be 5 on 2, then I square it, so this is the half squared, the coefficient of x, so it means my expression becomes x squared plus 5x plus 5 on 2 squared is equal to negative 4 plus 5 on 2 squared. Alright, so this side of the expression again is also a perfect square. So you take the x over here, x, then plus what we have over here, which is 5 on 2 squared. Okay, so if you expand this expression, you are going to get what you have at the top over here. So you always take where the s square, when you're solving the method of completing square, you have the s square term, and then the value that you added, if you take them and then square it together, it will give you the expansion you have at the top over here. So we have this as a perfect square, written as this is equal to negative 4 plus, now over here 5 on 2 will give me 2.5, and if I square it, that will give me 6.25 over here. So I still have my expression x plus 5 on 2 squared is equal to negative 4 plus 6.25 will give me 2.25. Right, so the first thing I need to do is to get rid of my square over here. So I do that by taking the root of both sides. So the root of x plus 5 on 2 squared will be equal to plus or minus the root of 2.25. So this cancels this. I have x plus 5 on 2 is equal to plus or minus the root of 2.25 is equal to 1.5. Right, so from here the next thing I need to do is to rearrange this equation. So I write x is equal to, if I send the 5 on 2 to the other side of the equal to sign, it becomes negative 5 on 2 plus or minus 1.5. So my x values are equal to negative 5 on 2 plus 1.5 or negative 5 on 2 minus 1.5. So this will be equal to negative 5 on 2 plus 1.5 will give me negative 1, or negative 5 on 2 minus 1.5 will give me negative 4. So my answers, or the root of the equation x squared plus 5x plus 4 is equal to negative 1 or negative 4. Okay, now you can also use the method of factorization to factorize this expression and you will still get negative 1, negative 4. Right, so let's have a look at another example. So we have to solve the following quadratic equation. So we have a question: solve the following quadratic equations using the method of completing the square. Okay, so we have we have 2x squared plus 4x minus 6 is equal to 0. Plus 6 is equal to 0. And then we have I, that is 3s squared minus 18x minus 27 is equal to 0. All right, so let's have a look at this. Okay, so the question doesn't end there. It says leaving your answer in set form. So leaving your answers in set form. Okay, so let's write down our solution. So the first expression we have is 2x squared plus 4x plus 6 is equal to 0. As always, the first thing you need to do is to make sure that the coefficient of the x squared term is 1. So I do that by dividing both sides by 2. Everything here by 2. So I divide by 2, by 2, by 2. So this cancels this. So I have x squared plus 4 on 2 will give me 2x plus 6 on 2 will give me 3 is equal to 0 on 2 will give me 0. So this becomes my new expression. Right, so from here I need to rewrite this expression. So I have x squared plus 2x is equal to negative 3. I send the 3 to the other side of the equal to sign. Now I add half square coefficient of x. So half of 2 will be 1. So that is half of 2 will be equal to 1. So I square 1. So I add it to this, both sides. So I have x squared plus 2x plus 1 squared is equal to minus 3 plus 1 squared. So this side, as usual, is a perfect square. So it means I can write x plus 1 all squared. So I have x plus 1 all squared is equal to minus 3 plus 1 squared is still 1. So I have this over here. So I have x plus 1 squared is equal to negative 3 plus 1 will give me negative 2. So from here I have to get rid of the square sign over here so that I can find my x. So I find the root of x plus 1 squared is equal to plus or minus the root of negative 2. This will cancel this. So I have x plus 1 is equal to plus or minus the root of 2. So x is equal to, I send a positive 1 to the other side, so it becomes minus 1 plus or minus the root of negative 2. Now note that root negative 2 will give you a complex number. Because it will give us a complex number, we do not want to solve it, because if you enter it into your calculator, it will be giving you an expression with an I inside, which is a complex number. That is why the question is demanding that we leave our answer in a set form. So my values of x are minus 1 plus the root of negative 2, or x is equal to minus 1 minus the root of negative 2. So this becomes my answer for this particular expression. Alright, so let's go ahead and find the solution for the second problem. So let me quickly erase. Alright, so the second expression is 3x squared minus 18x minus 27 is equal to 0. As usual, I need to make sure that the x squared term is standing alone, so I divide both sides by 3. So I have this cancels this, so I have x squared minus 18 on 3 is going to give me 6x, that minus 27 on 3 will give me a 9 is equal to, this will give me 0. Alright, so from here the next thing I need to do is to rearrange this equation. I write x squared minus 6s is equal to positive 9. I send the 9 to the other side of the equal to sign. So from here I add half square the coefficient of x. So half square the coefficient of x means that I have here half of negative 6, so half of negative 6 will give me a negative 3, and then I square that. So I have here x squared minus 6x plus into bracket negative 3 squared is equal to 9 plus into bracket negative 3 squared over here. So I can, this will give me a perfect square. Either I write this as 9 or like this, it's still going to give me a perfect square. So 3 minus 3 all squared. So I have x, this x over here, then minus this 3 minus 3 squared. If I expand this, I'm going to get this expression is equal to 9 plus negative 3 squared will give me 9. So I have over here x minus 3 squared is equal to 9 plus 9 will give me 18. So as usual, I need to get rid of the square by introducing my root. But if I introduce it over here, I need to add plus or minus. So it means this cancel this, and I have x minus 3 is equal to plus or minus the root of 18. Right, so from here I can write my x is equal to, I send the 3 to the other side of the equal to sign, it becomes positive. So I have 3 plus or minus the root of 18. So the values of x for this particular expression, or this equation, this equation is equal to positive 3 plus root 18, or positive 3 minus root 18. Okay, so this becomes the answer for my second expression, and as you can see, I'm leaving them in set form since they have root sign inside of them. So thank you so much for watching. This is how we use the method of completing the square to find the factors or the roots of a quadratic equation. So up next, we'll be looking at how to use the quadratic formula to solve quadratic equation. So thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic equation by using the quadratic formula. Alright, so without further ado, let's begin. Now, in our previous video, we did look at how to use the method that we call completing the square to solve for quadratic equations. We also established the fact that there are other methods of solving quadratic equations, such as the graphical method, as well as the use of the quadratic formula. Now, in this video, we want to use the quadratic formula, but before we do that, let's look at how the quadratic formula was derived before we use it to solve the quadratic equations. Now we established the fact that our quadratic equations are of the form ax squared plus bx plus c is equal to 0. Now we'll be using the method of completing the square here to derive the quadratic formula, and then we use it to solve any problem that will be given to us. Now I said in a previous video that in solving any equation that involves the use of the method of completing the square, always make sure that the x squared term is 1. So that means I have to divide each side over here by a to get rid of the a that is attached to the x squared side over here. So I have x squared plus b on ax plus c on a is equal to 0. Now after that, we have to rearrange this equation by sending the constant to the other side of the equal to sign. So I have this plus b on ax is equal to negative c on a. Now the next thing we do over here, we find half square the coefficient of x, half square coefficient of x. That is, we add half square coefficient of x to both sides of the equation. Now if you look at the coefficient of x is b on a, and half of that is equal to b on 2a. So if we square this becomes the half square. So this expression all becomes s squared plus b on ax plus b on 2a squared is equal to minus c on a plus b on 2a all squared. So this is what we get. So from here, now this is a perfect square, so we can rewrite it as just a plus b on 2a all squared. So it becomes a plus b on 2a all squared. If you like, if you expand this, you get this expression that you have over here. So this is what we have for this expression. So this is now equal to minus c on a plus this. If I expand this, it will give me b squared on 4a squared. So I can rewrite this as this 2a all squared is equal to, then I bring this guy first, so b squared over 4a squared minus c on a. Alright, so I maintain this side, x plus b on 2a all squared is equal to, the LCM between this and this will be equal to 4a squared. So I have 4a squared over here as my LCM. So 4a squared will go into 4a squared one time. 1 times b will give me b squared. Then minus a will go here 4a times. So 4a multiplied by c will give me 4ac. Alright, so from here I need to get rid of the square term to make x the subject. So I find the square root over here. So this becomes plus or minus the square root of this entire expression. Since we are introducing a square root sign, we introduce plus or minus. This cancels this, so we have x plus b on 2a is equal to plus or minus the root of b squared minus 4ac all over. Let me rewrite this as sorry, let me just maintain that 4a squared over here. Alright, so from here the next thing I do is that the 4a squared over here that I have, I can rewrite this equation as, instead of writing 4a squared, I can write 2 squared a squared. Okay, so it means that these guys will cancel the root that will be at the bottom over here. So I'll just have this expression will be x plus b on 2a is equal to plus or minus. The root is not just affecting just the top, that is b squared minus 4ac on 2a. Now the root doesn't extend to the bottom again, since the 4a squared is now 2a. Alright, so from here I can just maintain my x here and bring this guy to the other side of the equal to sign. So I have my x is equal to minus b on 2a plus or minus the root of b squared minus 4ac on 2a. Now you realize that we have 2a here, a common denominator, so we can rewrite this entire equation as s is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. Now this expression, that is s is equal to minus b plus or minus the root of b squared minus 4ac all on 2a, this equation is what we are calling the quadratic formula. Quadratic formula. So once you've been given a quadratic equation, you substitute the value of your a, b, and c into this equation, you can get the root of the equation very easily. So we obtain this information by using the method of completing the square on the general expression of a quadratic equation to get this formula. So this is the formula we'll be using in today's video to solve for problems. Right, so let's go ahead and look at an example. So we have to use the quadratic formula to solve the following equation. So we have 3x squared minus 6x plus 2, and then x squared minus 2x plus 2. All right, so this is the equation that we are supposed to solve using the quadratic formula. So let's look at that. Now if you look at these expressions really well, you realize that we cannot factorize this equation, and so we need to use another method, that is either the method of completing the square or the quadratic formula. But since the question is saying that we should use the quadratic formula, let's do that. So in order to use the quadratic formula, we have the equation 3x squared minus 6x plus plus 2 here is equal to 0. Alright, so that means that my a term, which is the coefficient of the x squared term, is 3. My b, which is the coefficient of the x term, is minus 6. And then my c, which is the constant, is 2 over here. So that is 2. Now I can write my formula. My formula is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So this is my formula for finding the value of x. So I do the substitution. I have minus b is 6, b is 6, so minus 6 plus or minus the root of b squared is minus 6 squared minus 4, a is 3 multiplied by c, which is 2, all on 2 into bracket a, which is 3. So this means that my x is equal to plus 6, negative will give me positive, plus or minus the root of, now minus 6 squared will give me 36, minus, now 3 times 2 will give me 6 multiplied by 4, that will give me 24, all on 2 multiplied by 3 will give me 6. So x is now equal to 6 plus or minus the root of 32 minus 24 will give me 12, all on 6. So my x values are 6 plus root 12 on 6, or 6 minus root 12 on 6. Alright, so 6 plus root 12 on 6, this will give me the value 1.577, or 6 minus root 12 on 6 will give me 0.423 as my answer for x. So if the question demands that you leave your answer in a set form, you can leave your answer here. This is also correct. But if not, you just use your calculator, punch these guys into the calculator, and get your answer in this form, always to 3 decimal places. All right, so let's go ahead and find the second example. Let's do that. So the second example, we have x squared minus 2x plus 2 is equal to 0. This means my a term is 1, my b is negative 2, and my c, the constant, is 2 over here. So my quadratic formula is x is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. So my x is equal to minus b is minus into bracket minus 2 plus or minus the root of b squared will be minus 2 squared minus 4. A and c is 1 multiplied by 2 all over 2a. So my x is now equal to, this will become positive 2 plus or minus the root of, this is 4 minus, this is 2 multiplied by 4 will give me 8, so this becomes minus 8 all over, the a here is 1, so this becomes 2. So my x is now equal to 2 plus or minus the root of 4 minus 8 will give me a negative 4. So I have negative 4 on 2. So my x values are 2 plus root negative 4 on 2, or 2 minus root negative 4 on 2. Alright, now root of negative number will give you a complex number. So we can leave our answer as it is over here in the complex in the set format, because if we point this into the calculator we'll be getting 2 plus I root negative 4 and some other stuff, which is a complex number. We don't want to deal with complex numbers in today's video, so we can just leave our answer in a set form like this, and that will be alright. So this is how we use the quadratic formula to solve quadratic equation and get the roots of the equation. So thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video we want to talk about the discriminant and nature of quadratic equations. Right, so in our previous tutorial we did look at how to use the quadratic formula to solve quadratic equations. Now in this video we want to look at how to determine the nature of a quadratic equation. Now some quadratic equations do not have real roots. That is, if you solve them you get complex root or numbers that are difficult for you to simplify. A typical example is this expression x squared minus 2x plus 2 is equal to 0. If you were to solve this equation, you realize that you have the expression x is equal to 2 plus or minus the root of negative 4 on 2. So this expression gives us a complex number or a complex root, and so therefore we say that this particular type of equation does not have real roots. Okay, so it has no real roots. Now how can we identify that an equation has real root or not? Now there are other equations that if you solve them you're going to get the two values of x to be, let's say for instance 5, the other value will also be 5. For this case we say we have repeated roots, and there are those that you solve, you have x is equal to 1 and then x is equal to, let's say, 4. These are what we call, this type are what we call the real roots. This is what we call the repeated roots, since we have repeated numbers. And the ones that will give us a complex answer, or will be forced to leave the answer in a set format, we say it has a complex root or no real root. Now how can you identify that an equation has either a complex root, real roots, or repeated root? How can you identify that? So let's look at how we can identify that. Now we said that our quadratic formula is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. Now the expression under the root sign over here, this expression, which is b squared minus 4ac, this expression is what we call the discriminant. This is the expression that tells us whether a particular quadratic equation is going to have two real roots, repeated root, or no real root, or a complex root. So let's look at the conditions for us to determine whether a quadratic equation has no real root, complex root, or repeated root. Now the first condition is if the discriminant, that is b squared minus 4ac, is greater than 0 or is positive. If b squared minus 4ac is greater than 0 or is positive, then the equation has two real roots, has two real and distinct roots. Let me put it that way. Two real and distinct roots. That is, the roots are not going to be the same. One answer might be 4, one answer might be 1. They're just going to be different answers. So when b squared minus 4ac is greater than 0 or is positive. Now if you draw this type of graph, you realize that the parabola for the quadratic equation is in this form. It cuts the x-axis. Now the values at which it cuts the x-axis over here, these extreme points, are the two real roots that we are talking about. They are the two real and distinct roots. Okay, and that only occurs, you have this type of graph if you have the discriminant, which is b squared minus 4ac being positive or greater than 0. Now the second expression is when we have b squared minus 4ac less than 0 or is negative. Okay, so this one means it is negative. When this expression gives you a negative result, then the equation has no real root. The equation has no real roots, or some people will say it has a complex root. Now this type of graph, if you plot it, you realize that if you have the x-axis, this is your x-axis, and you plot this type of graph, you see that the curve, the parabola, will not cut the x-axis at any point. So for you to get the answer or the x value that make the quadratic equation equal to 0, it has to be a complex number since it has not cut the x-axis. Now the last expression is when we have b squared minus 4ac being equal to 0. Now when it is equal to 0, it means the equation has one repeated root. Repeated root means that if the answer is 4, both answers of x will be 4, 4. If it is 5, it's 5, 5. If it's negative 1, it's negative 1, negative 1. Nothing is going to be different. And if we draw the graph of that, let me draw that over here. You realize that the graph, the parabola, looks something like this. It only touches the x at one point and then goes back up. So this is it. So if it is positive, it cuts the x-axis as 2 points, and that is what we call two real and distinct roots. If it is less than 0 or is negative, it does not cut the x-axis at all, and so forth. It has no real root or it has a complex root. If it is equal to 0, it means that it has one repeated root. Alright, let's go ahead and look at some expressions to actually appreciate what we are talking about. So we have to find the nature, we have to find the value of the discriminant and use it to find the number of real roots for each of the following equations. So we have s squared minus 3x plus 4 is equal to 0. S squared minus 3x minus 4 is equal to 0. We have 3x squared plus 4x plus 1 is equal to 0. And then the last one, IV, is x squared plus 10x plus 25 is equal to 0. Now the question is asking us to find the value of the discriminant and use it to find the number of real roots for each of the following equation. Right, so for us to find the discriminant, we use the expression b squared minus 4ac. So in this first case, this first equation, our a term is 1, which is the coefficient of the s squared term. Our b is negative 3, the coefficient of the x term. And then our c is the constant 4. So if we substitute this into this equation, we are going to have negative 3 squared minus 4 into bracket 1 multiplied by 4. So this becomes negative 3 squared is 9 minus 4 into bracket 4 over here, and this will give me 9 minus 4 multiplied by 4 is 16, and so 9 minus 16 will give me negative 7. Now, since this expression or the discriminant is giving me a negative value, it means that b squared minus 4ac is less than 0, and hence this particular equation, the first equation, has no real root. So x squared minus 3x plus 4 is equal to 0 has no real roots, or it has complex roots. It has complex root. It means you're going to be getting a complex number. You will be having a negative under the root sign. All right, so let's look at the second expression, II. We have x squared minus 3x minus 4 is equal to 0. All right, so let's look at something. Now, if we look at this equation, our a term is equal to 1, our b is negative 3, our c is negative 4. All right, so let's determine the nature of this particular root. So that would be b squared minus 4ac. That would be negative 3 squared minus 4 multiplied by 1 multiplied by negative 4. So this will give me 9 multiplied by 9 minus 4 multiplied by negative 4, and this will give me 9 plus 16, and this is equal to 25. Now, because this is a positive value, okay, it means that the discriminant, which is b squared minus 4ac, is greater than 0, and therefore means that this expression has two real roots. It means that the expression has two real and distinct roots. Don't worry, we'll be looking at this equation. We'll be solving this equation, the first equation. We'll be solving the equation to see whether truly we'll have a complex root or the no real root that we are talking about. Now you can solve this on your own. So let me put asterisk here. You can solve the second expression on your own to see whether you not get two real answers for this particular example. Now let's move on to III. Let me get some space. Or no, let me just continue. All right, so the third expression we have III. We have 3x squared plus 4x plus 1. Okay, so let's determine the nature of the root. So that will be b squared minus 4ac. So this is equal to, our b is positive 4, so we have 4 squared minus 4 into bracket, a is 3 here multiplied by 1. So this will give me 4 squared is 16 minus 4 multiplied by 3 multiplied by 1 will give me 3. So this is 16 minus 12, and this is equal to 4. Okay, we can see that the answer here is positive, and therefore means b squared minus 4ac is greater than 0, and therefore this equation, the equation has two real and distinct roots and distinct roots. Now let's look at the last expression that we have, IV. The last expression that we have is x squared plus 10x plus 25 is equal to 0. As we can see over here, given to us over here, this is the last expression. So let's look at that. So to find the nature of this particular equation, we have b squared minus 4ac, okay, and this is equal to, our b is 10, so we have 10 squared minus 4 into bracket, our a is 1, our c is 25. So this is equal to, this is equal to 10 squared is 100 minus 4 multiplied by 25 over here, that is 1 multiplied by 25 will give us 25. So we have here 100 minus 4 multiplied by 25 also give us 100, and this is equal to 0. Now the fact that b squared minus 4ac is equal to 0 means the equation has one repeated root, roots. Okay, yes, one repeated root. So I'm going to solve this expression to see whether we are going to have one answer 2 times and then I'm going to solve this first equation. So the first and then the last equation, I'm going to solve the first one to see if we'll get a complex root like we've said, whether we'll get a complex root like we've said over here. Then I'll solve the last one to see whether we will have repeated roots as we've seen over here. So let's look at that. So the first expression, this is just for verification. We have x squared minus 3x plus 4 is equal to 0. Let's see whether we'll get complex roots after we solve this equation. So we have our a term is 1, our b term is minus 3, our c term is 4. So I'll be using the quadratic formula in this case. So x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So it means that I have minus b, which is 3, minus 3 plus or minus the root of minus 3 squared minus 4 into bracket 1 multiplied by 4 all over 2a, and then the a in this case is 1. So my x is equal to negative will give me positive, so I have 3 plus or minus the root of this will give me 9 minus 4 multiplied by 4 will give me 16. So I have 16 here on 2. So this means my x is equal to 3 plus or minus the root of 9 minus 16 will give me 7, which is negative 7 on 2. So my two x values will be 3 plus root negative 7 on 2, and then x will be 3 minus root negative 7 on 2. The further we have a negative number under the root sign will give us a complex value. So if we punch this into the calculator, we'll be getting 3 plus I root 7 something. So that is a complex number, and that was what we found after finding the discriminant of the equation. So from the discriminant, we realize that it has no real root or it has a complex root, and after solving the equation, we realize that that is true because we are not getting integers or even decimals as our answer. So this is complex roots. Now let's look at the last expression. So the last expression or the last equation that we solved was x squared plus 10x plus 25 is equal to 0. And when we solved this expression, we had one repeated root because it was equal to 0, so it will give us repeated root. So we are expecting the same answer twice. All right, so let's go ahead. Our a term here is 1, our b term is 10, our c is 25. So still I'll be using the quadratic formula again. So I have minus b plus or minus the root of b squared minus 4ac all on 2a. So this means my x is equal to minus b, which is 10 here, plus or minus the root of b squared will be 10 squared minus 4 into bracket. My a is 1, my c is 25. All this on 2a, which is 1. So my x is equal to minus 10 plus or minus the root of 10 squared will be 100 minus 4 multiplied by negative 25 will give me negative 100 all on 2. So my x is equal to negative 10 plus or minus the root of 100 minus 100 will give me 0 on 2. So x is equal to root 0 is still 0, so I'm going to have minus 10 plus or minus 0 on 2. So my two x values are minus 10 plus 0 on 2, and then the other x value is minus 10 minus 0 on 2. Now this is minus 10 plus 0 is still minus 10 on 2 will give me minus 5. Minus 10 minus 0 is still minus 10 on 2 give me negative 5. So we get to realize that we are having two repeated answers. Okay, so we have negative 5, and that is what we mean by one repeated root, because it's the same number that is repeating twice. So we could see that just by using the expression b squared minus 4ac, which we are calling the discriminant, we are able to predict whether the answer will will be repeated roots, complex roots, or two real roots. And that, my brothers and sisters, that is what we call the discriminant. This powerful equation is what we are calling the discriminant of a quadratic equation, and this equation helps us to determine the root or the nature of a quadratic equation. So thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve linear simultaneous equations. Now, simultaneous equations are equations that have multiple variables. They may have 2 or 3 variables that are unknown to us, so we'll have to solve them simultaneously or together to find the values of those variables. Now, there are 2 ways of solving simultaneous equations. We have one method we call the elimination method, and then we have another method we call the substitution method. But for the sake of today's video, we'll be looking at the elimination method, and in the subsequent one, we'll be looking at the substitution method. Alright, so let's try an example. So say we have 6h plus d is equal to 40 as our equation 1, and then we have 4h plus 3d is equal to 36 as our equation 2, and we are to solve these 2 equations using the elimination method. Now, when you are using the elimination method, what you need to do is you need to multiply your equations, equation 1, equation 2, by a number or a value. You do that with the sense that you want to get one of these unknown variables to be the same so that you can cancel out and you find the other. So for instance, I can decide to make the value of h and h here the same so that they will cancel each other out if I subtract them, and then it will be only left with d, and I can find my d first. Or I can decide to make d and d the same, and then I cancel them out. So for this particular example, I'm going to make d here the same. So what I will do is I will multiply equation 1 by 3. Then I multiply equation 2 by 1. I'm multiplying equation 1 by 3 because I want to make the d here to be 3d, and then I'm multiplying equation 1 because I want to still maintain this so that I can cancel the 3d out. So if I multiply equation 1 by 3, I'm going to get 3 multiplied by 6 will give me 18h here plus 3d is equal to 3 multiplied by 40 will give me 120. So you can say this is my equation 4. Then I multiply this equation 2 by 1, is still going to be the same. So I have 4h plus 3d is equal to 36. Now what you do is, you can say this is equation 5. What you do is you subtract this equation. So you can say equation 4 minus equation 5. Okay, so that is what you do over here. So you are going to have 18h plus 3d is equal to 120 minus 4h plus 3d is equal to 36. So what do we get over here? Now 18h minus 4h will give us 14h. This will give us 14h over here. So this will give us 14h. Then plus 3d minus 3d will give us 0. So we have 0 here is equal to 120 minus 36 will give me 84 as my answer. So I have here 14h is equal to 84. To make h the subject, I divide both sides by 14. Therefore, my h becomes 84 on 14, that will give me 6. Now that I have my value of h to be 6, I can put h back into either equation 1, 2, 3, or 4 to get the value for d. So putting h is equal to 6 into equation 1 to get the value of my d, I have 6h plus d is equal to 40. That means I have 6 multiplied by 6 plus d equals 40. So my d becomes 40 minus 6 multiplied by 6 will give me 36. I bring it here, it becomes negative, so minus 36, and so my d is equal to 40 minus 36, and that will give me 4. So the value of my d is 4, and then the value of h is 6 as seen over here. Right, so let's have a look at another example. So we have to solve the following equations, equation 1 and 2, using the method of elimination. So we have 1, 3x plus 5y is equal to 12. This is our equation 1. Then we have 2x minus 6y is equal to minus 20. That's our equation 2. Then we have II. We have x plus 4y is equal to 16. And then 3x plus 5y is equal to 20. This is equation 1, our equation 2. Alright, so let's solve the first example using the elimination method. So if I look through my equation 1 and equation 2, I realize that I can try and cancel out the x first so that I find y, and I do the substitution back to get my x. So I will decide to say multiply equation 1 by 2 because I want to make this guy 6. Then I multiply equation 2 by 3 to also make it 6. So if I multiply equation 1 by 2, I'm going to have 6x plus 10y is equal to 24. You can make this your equation 3. And then I can say 2x minus 6y is equal to 20. I need to multiply it by 3. So if I do that, I'll get 6x. 3 multiplied by 6 will give me 18y is equal to 3 multiplied by 20 will give me negative 60 over here. So this becomes my equation 4. From here I can see, let me have okay, so equation 3 minus equation 4. So that will give me 6x plus 10y is equal to 24 minus 6x minus 18y is equal to negative 60. Right, so 6x minus 6x will give me 0x, so it is 0, so I can leave that. Now 10y minus minus 18 becomes 10y plus 18, and that will give me 28y is equal to 24 minus 60. This 24 here minus this minus 60, so it becomes 24 plus 60. That 24 plus 60 will give me 84. So I can divide both sides by 28, and then this will give me y value, which is equal to 3. 84 divided by 28 will give me 3. So putting y equals 3 into equation 1, okay, you can put it into equation 2, equation 1, equation 3, or equation 4, any of them. So if I do that, I have 3x plus 5 multiplied by 3 is equal to 12. So I have here 3x is equal to 12. 5 multiplied by 3 is 15. Bring it here, it becomes negative, so minus 15. So 3x is equal to 12 minus 15 will give me negative 3. So the value of my x, so I divide both sides by 3x is equal to minus 3. Divide both sides by 3 by 3. My x is equal to negative 1. So it means that the value of my y is 3, the value of my x is negative 1. Alright, so let's go ahead and solve the second aspect of this equation. So let me quickly erase. Alright, so for II we have x plus 4y is equal to 16 as our equation 1. Then we have 3x plus 5y is equal to 20 as our equation 2. Now I see that if I multiply equation 1 by 3 and this by 1, I will get 3x here. I can cancel easily. So I do that. So I multiply equation 1 by 3, and I multiply equation 2 by 1. So if I do that, I'm going to have 3 multiplied by x will give me 3x, plus 3 multiplied by 4 will give me 12y, is equal to 3 multiplied by 16 will give me 48. If I use 1 to multiply everything here, I'll still get 3x plus 5y is equal to 20. Now all I need to do is to subtract. Okay, let me say this is equation 3, equation 4. So I can subtract equation 4 from equation. I can subtract equation 4 from equation 1. So let me do that. So if I do that, I'll get 3x minus 3x will give me 0x here. Then I have 12 minus 5y will give me, this will give me plus 7y is equal to, I have 48 minus 20, and that will give me 28. So it means I have 7y is equal to 28. I divide both sides by 7. By 7, I have my value of y to be equal to 4. Now, putting y equals 4 into, let me put it into equation 2 this time around, I'll get, over here we have 3x plus 5y, this is 4, is equal to positive 20. So we have 3x plus 20 here is equal to 20, and this implies that we have 3x is equal to this 20 here minus this 20, because we are sending it to the other side of the equal to sign. So we have 3x is equal to 0. We divide both sides by 3. We have x is equal to 0. So it means that my x is 0 and then my y is equal to 4. So this is how we solve simultaneous equation by the method of elimination. Now in the next video, we'll be looking at how to solve simultaneous equation using the substitution method. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve linear simultaneous equations by the method of substitution. So let's start with an example. Say we have 6h plus d is equal to 40 as our equation 1, and then we have 4h plus 3d is equal to 36 as our equation 2. If we are to solve this simultaneous equation using the method of substitution, this is what we do. So we take any of the equation, whether equation 1 or equation 2, try to make one of the variables the subject and substitute it into the next equation to get your answer. So in this case, I'm going to say making d, this d here, the subject in equation 1. So making d the subject in equation 1. So I want to make d the subject here. So I have 6h plus d is equal to 40. It means my d is equal to 40 minus 6h. So this becomes my subject after making d the subject. So let me name this equation 3. So I can then say putting equation or substituting equation 3 into equation 2. Please, after you've made d the subject in equation 1, don't substitute it back into equation 1. Substitute it into the next equation. So I'm substituting it into equation 2 over here. So I have 4h plus 3 into bracket 40 minus 6h is equal to 36 over here. So from here I have 4h plus 3 multiplied by 40 will give me 120 minus 3 multiplied by 6 will give me 18h. This is equal to 36. So I have here 4h minus 18h is equal to this. So let me maintain the 120 here. So 120, I bring this side to the other side, so it becomes minus 36 is equal to, I send the h to the other side of the equal to sign. So I have 18h here minus this guy, which is 4h. So from here I have 120 minus 36 will give me 84 is equal to 18h minus 4h will give me 14h. So I divide both sides by 14 to make my h stand alone. So the value of my h is now equal to 84 minus 14 is equal to 6. Now that I have the value of h, I can substitute it into any of these equations, whether equation 1, 2, or 3. But I'm going to substitute it into equation 3 since it already has d as the subject. So putting back h equals 6 into equation 3. So it means my d will be equal to 40 minus 6 multiplied by 6 as the value of h. So my d is equal to 40 minus 6 times 6 will give me 36. And so therefore my value of d is 40 minus 36, and that will give me the answer 4. So my h is equal to 6, my d is equal to 4. Now if you substitute these values back into this equation, that is h equals 6 and d equal to 4, you are going to get these answers for each of the equations. Alright, so let's proceed to look at more examples. So we have to solve the following equations by the method of substitution. So we have 3x plus 5y is equal to 12, our equation 1, and then we have 2x minus 6y is equal to negative 20 as our equation 2. Alright, so let's look at that. Now the first thing I want to do is to make this x the subject in equation 1. So making x the subject in equation 1. So by making x the subject here, I have 3x plus 5y is equal to 12. So it means I have 3x is equal to, I send the 5y to the other side of the equal to sign. So I have here 12 minus 5y. To make my x stand alone, I divide both sides by 3. So my x is now equal to 12 minus 5y on 3. So this expression becomes my equation 3. So putting equation 3, which is this new equation, into the second equation over here, into equation 2, I'll have the expression 2 into bracket. Now my x is 12 minus 5y on 3. Then minus 6y is equal to minus 20. Alright, so from here, what I will do is I will expand this bracket first. So 2 multiplied by 12 will give me 24. Then 2 multiplied by 5 will give me 10y, all on 3, minus 6y is equal to minus 20. Now we still have a fraction over here, so I'm going to multiply through by 3. If I do that, I have 3 multiplied by 24 minus 10y on 3 minus 3 multiplied by 6y is equal to minus 20 multiplied by 3. This will cancel this, so I have 24 minus 10y minus 3 multiplied by 6 will give me 18y is equal to minus 20 multiplied by 3 will give me minus 60. Alright, so from here, I have here minus 10y minus 18y. So this will give me minus 28y is equal to minus 60. I send the 24 to the other side of the equal to sign, it becomes minus 24. So I have minus 28y is equal to minus 60 minus 24 will give me minus 84. So I divide both sides by minus 28. Minus 28, the negative cancel the negative, this cancel this. So my y is equal to the negative cancel this. 84 on 28 will give me the value 3. So it means that my y is equal to 3. Now substituting or putting y equals 3 into equation 3 here to get the x is into equation 3, I'm going to have my x to be equal to 12 minus 5 into bracket 3 all on 3. So my x will be equal to 12 minus 5 multiplied by 3 is 15 on 3, and 12 minus 15 is negative 3 on 3, and x will be equal to negative 1. So it means that the value of my y is 3, the value of my x is negative 1. Alright, let's go ahead and look at another example. So we have x plus 4y is equal to 16, and then 3x plus 5y is equal to 20. So let me make this my equation 1, this my equation 2. Alright, so from here I realize that making x the subject in equation 1 is super easy. So I'm going to say make x the subject in equation 1. Now if you don't know how to make a variable the subject, I'll leave the link in the description of the video for a change of subject where you know how to make a variable the subject of an equation. So from here I have x plus 4y is equal to 16. So I can leave my x here, and this is equal to 16. I send this guy to the other side, becomes minus 4y. So this becomes my subject. After making x the subject, this becomes my expression. So this, I will name it equation 3. Alright, so from here I can say substitute. Let me use substitute now. Substitute equation 3 into equation 2. Now if I do that substitution, I have 3 into bracket the x, which is 16 minus 4y plus 5y is equal to 20. Now 3 multiplied by 16 will give me 48. 3 multiplied by 4 will give me 12y plus 5y is equal to 20. So I have over here 48. Then I bring the 20 to this side, it becomes minus 20 is equal to, I send the y coordinate to the other side, so it becomes 12y minus 5y. So over here I have 48 minus 20 will give me 28. This is equal to 12y minus 5y will give me 7y. So I divide both sides by 7. So my y is equal to 28 on 7 will give me the value of 4. Now putting back y is equal to 4 into equation 3, I have x is equal to 16 minus 4 into bracket y value, which is now 4. I have x is equal to 16 minus 4 multiplied by 4 is 16. So my x is equal to 16 minus 16 will give me a value of 0. So my x is 0, my y is 4. And you can see that if we substitute this guy back, x, which is 0, plus 4 multiplied by 4 will give me 16. And then 3 multiplied by 0 is 0, plus 5 multiplied by 4 is 20. So that is the 20 we have over here. So thank you so much for watching this video, and I'll see you in the next one. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve non-linear simultaneous equations. So let's begin. So what is the difference between a linear simultaneous equation and non-linear simultaneous equation? Now for a linear simultaneous equation, say in the form of x and y, we have the equation expressed, let's say 7x plus 2y is equal to, let's say, 11. So this is a linear simultaneous equation because we can see we have two variables, x and y, and then a constant term in this equation. Now they are not raised to any power, so we call them linear simultaneous equation. Now for a non-linear equation, we are having, let's say, something like 7x squared plus 2y is equal to 11. The moment we have one of the variables raised to a power, then it becomes a non-linear simultaneous equation. So assuming we are given let's say 7x plus 2y is equal to 11 and 7x squared plus 2y is equal to, let's say, 14 as an equation to solve. We need to solve this because we are solving these two equations. It becomes a simultaneous equation, but it is a non-linear simultaneous equation. It's a non-linear because the second equation has an s squared term. Because it has an s squared term, if we want to solve this equation, we need to solve it via the substitution method. Of solving simultaneous equations. So we need to use the substitution method. Right, so let's have a look at some examples to appreciate what we are talking about. So say we have x plus 2y is equal to 7 as equation 1, and then we have another equation, x squared plus y squared is equal to 10 as our equation 2. How do we solve these two equations to find the value of x and y? Right, so from here, using the substitution method, the first thing we do is to make one of the variables the subject, and I will do that by making x the subject in equation 1. So I'm going to say making x the subject in equation 1. So if I make x the subject over here, I'm going to have x is equal to 7, then I bring the 2y to the other side of the equal to sign, it becomes minus 2y. So from here, I'll say substitute x into equation 2. Okay, so it means wherever I see x, I should place 7 minus 2y in there. So I have here 7 minus 2y in place of the x here, and I squared it, plus y squared is equal to 10. Okay, so from here I can expand this bracket and then I solve for my y. So from here I can bring 7 out, then into bracket 7 minus 2y. Okay, so let me not jump that step, let me take it one after the other. So from here it means I have this bracket, the content in the bracket twice. So I have into bracket 7 minus 2y multiplied by 7 minus 2y plus y squared is equal to 10. So I can now use the content over here to multiply the content over here. So I use the 7 first, 7 into bracket 7 minus 2y. Then I have the second term over here, minus 2y. I use it to multiply this, so 7 minus 2y again, plus y squared, this y squared is equal to 10. Alright, so 7 multiplied by 7 will give me 49, minus 7 multiplied by 2 will give me 14y, minus here will also give me 14y, then here will give me plus 4y squared, plus another y squared is equal to 10. So from here I have 49 minus 14y minus 14y will give me minus 28y. So I have minus 28y here, then plus I have 4y squared and then y squared, that will give me 5y squared is equal to 10. Okay, so from here I can see that I have y squared, y, and a constant, another constant. So I need to group items. So I'm going to rewrite this whole equation, bring in 5y first. So I have 5y squared minus 28y plus the 49 here. Then I bring the 10 over here to this side of the equal to sign, so it becomes minus 10 is equal to 0. So I have 5y squared minus 28y plus 49 minus 10 will give me 39. So over here I have 39. So plus 39 is equal to 0. So we can see that we have this equation is what we call a quadratic equation. This is a quadratic equation. So from this quadratic equation, I need to solve it by method of factorization, and then I find my values of y. So I use the coefficient of to solve quadratic equation. You use the coefficient of the y squared term over here, which is 5 over here, to multiply the constant. So 5 multiplied by 39 will give me 195. Now which two numbers will I multiply to get 195 but add to get negative 28. So negative 15, negative 13 will do that. Negative 15 multiplied by negative 13 will give me 195, but if I add them, it will give me negative 28. So I'm going to use that. So I have 5y squared minus 15y minus 13y plus 39 is equal to 0. So from here, I can go ahead and do my factorization. So between 5y squared and 15y, I can see that 5y is common, so I factor out 5y. Then I have into bracket y minus 3 over here. Then between minus 13y and 39, I can see that minus 13 is common, so I have minus 13 outside bracket. Then into bracket y minus 3, bracket close, is equal to 0. So I have 5y minus 13 and then y minus 3 is equal to 0. From here, I can now equate each of these brackets to 0. It means I have 5y minus 13 is equal to 0, and then y minus 3 is equal to 0. So over here, 5y equals 13, and therefore y is equal to 13 on 5. On the other hand, we have y to be equal to positive 3. So it means that after solving for y, we have two values of y. But note that this is simultaneous equation in two variables, that is x and y. So we have two values for y. So it means we have to get their corresponding x values. So let's do that. So let me use another color. So if y is equal to 13 on 5, okay, then it means the x value from here is equal to 7 minus 2 into bracket 13 on 5. So x will be equal to, if you compute this into your calculator, you're going to get x to be 1.8. Now if y is equal to 3, then it means that I'm going to have my x to be equal to 7 minus 2 into brackets 3, and that will give me 7 minus 6, and x is equal to 1. So therefore, my answer is s is equal to 1.8 and y is equal to 13.5, sorry, 13 on 5, or x is equal to 1 and y is equal to 3. You can see that we have two sets of answers over here because one of them is in a form that we are calling a non-linear simultaneous equation form, a non-linear form. So we are having two sets of answers for this particular example. All right, so let's go ahead and solve more examples to appreciate how to solve non-linear simultaneous equation. All right, so we have to solve the following pair of equations. So we have we have k squared plus km is equal to 8, and then we have m is equal to k minus 6. This is equation 1, this is equation 2. Then we have we have x squared minus 2y squared is equal to 8, and then we have x plus 2y is equal to 8. Equation 1, equation 2. All right, so let's go ahead and look at how to solve these two problems. So solution. So I have k squared plus km is equal to 8 as my first equation. I have m is equal to k minus 6 as my second equation. Now if you look at equation 1 and equation 2, they've already made one of the terms the subject in equation 2, so there's no need you make anything the subject. From here you can straight away go ahead and say substituting m into equation 1, or substituting equation 2 into equation 1, you are going to have k squared plus k into bracket, the m now becomes k minus 6. This is equal to 8. So from here, let's go ahead and expand the bracket. So I still have k squared here, plus k multiplied by k will give me k squared. K multiplied by negative 6 will give me negative 6k is equal to 8. So k squared will give me 2k squared minus 6k. I bring the 8 to the other side of the equal to sign, it becomes minus 8 equals 0. So over here, I have a quadratic equation, but I can see that these terms can be divided. So I divide both sides by 2 by 2 by 2 to simplify it. So I'm going to have k squared minus 3k minus 4 is equal to 0. So this becomes my quadratic equation that I'm going to factorize. So let me rewrite that here. K squared minus 3k minus 4 is equal to 0. Now the coefficient of the k squared term here is 1. So if I use that 1 to multiply negative 4, I still have negative 4. Now which two numbers will I multiply to get negative 4? But if I add them, I get negative 3. So you see that negative 4, positive 1 will do that for us. So let's go ahead and use that. So negative 4 multiplied by positive 1 will give us negative 4. But if we add them, we get negative 3. So we have here k squared minus 4k plus k minus 4 is equal to 0. So I can factor k out here. So I have k outside bracket, k minus 4, then plus 1 outside bracket, k minus 4 is equal to 0. So I have k plus 1 into bracket, then I bring one of the repeated roots, k minus 4 is equal to 0. So if I equate this guy to the equal to, so I have k plus 1 is equal to 0, or k minus 4 is equal to 0. So over here I'm going to have k is equal to negative 1, or k is equal to positive 4. Now that we have the k values, note that we need to find the corresponding m values for each of these k's. So when k is equal to negative 1, okay, so when k equals negative 1, let's find the m. So m will be equal to negative 1, which is the k here, minus 6. So m will be equal to what? Negative 7 as our answer. Now let's look at when k is equal to 4. When k is equal to positive 4, we have the m to be equal to 4 minus 6, and then that will give us m to be equal to negative 2. So our solution set is k is equal to negative 1 and m is equal to negative 7, or k is equal to 4 and m is equal to negative 2. So this becomes the answer for the first set of equation. Alright, so let's look at the second example that we have over here. So this particular example. So let me get some space. Okay, we have x squared minus 2y squared equals 8, and then we have x plus 2y is equal to 8. This is equation 1 and this is equation 2. Alright, so let's go ahead and solve this. So as usual, I want to make my x the subject in equation 2. So I'm going to say making x the subject in equation 2. So if I make x the subject here, I'm going to have x is equal to 8 minus 2y. So I brought the 2y to the other side of the equal to sign, leaving x alone. So from here I can say substituting the value of x, which is 8 minus 2y, into equation 1. So I'm going to have into bracket 8 minus 2y squared minus 2y squared is equal to 8. So this means I have 8 minus 2y, another 8 minus 2y minus 2y squared is equal to 8. So from here I can go ahead and expand the bracket. So I'll have 8 into bracket 8 minus 2y, then I use the negative 2y to also multiply the bracket. So negative 2y, 8 minus 2y, and this minus this 2y, so minus 2y squared is equal to 8. Alright, so from here 8 multiplied by 8 will give me 64. 8 multiplied by 2 will give me 16, so I have 16y here. So this is also 16y. The negative 2y multiplied by negative 2y will give me positive 4y squared, minus the 2y squared over here is equal to 8. So I have here 64, this guy, negative 16y minus 16y will give me negative 32y. Then I have plus 4y squared minus 2y squared will give me 2y squared is equal to 8. Okay, so from here, let me rearrange this equation. Let me bring 2y squared first. So I'm going to have 2y squared, then minus this 32y. Then I write plus 64. And then I'm going to bring this 8 to the other side of the equal to sign. So it becomes minus 8 is equal to 0. So from here, I have 2y squared minus 32y. Now, 64 minus 8 will give me plus 56. This is equal to 0. Right, so I can see that I can divide through each of the coefficients of the y squared, the y, and then the constant. I can divide through by 2. So let's do that. So if I divide through by 2, 2, 2, and 2, I'm going to have y squared minus 16y, then plus 28 is equal to 0. So now I have a much more easier equation for me to factorize. So let's go ahead and factorize this equation. So let me erase this guy here. Okay, so we have our equation y squared minus 16y plus 28 is equal to 0. I use the coefficient of the y squared term to multiply 28. So 1 multiplied by 28 is 28. Now, which two numbers will I multiply to get positive 28? But if I add them, if I add or subtract, I'm going to get negative 16. Alright, so 14 and 2 will do that. So negative 14, negative 2 will give me positive 28, but negative 14 plus negative 2 will give me negative 16. So I have here y squared minus 2y minus 14y plus 28 is equal to 0. So from here I can factor out y. So I have y outside bracket, y minus 2. Then between 14y and 28, I can see that 14 is common, so I have minus 14 into bracket y minus 2 is equal to 0. So from here I have y minus 14 as one of my factors, then I have y minus 2 also as another factor. So from here I equate both of them to 0. I'll get y is equal to 14 or y is equal to positive 2. Now remember that we did make x the subject. So let's find the corresponding x value. Alright, so when y is equal to 14, we said that x was equal to 8 minus 2y. So it means I'll have here 8 minus 2 into bracket 14, and this will give me 8 minus 28, that will give me negative 20. Okay, this is negative 20. So when y is equal to positive 14, x is equal to negative 20. Now when y is equal to 2, I'm going to have x is equal to 8 minus 2 into bracket 2, and this will give me 8 minus 4, and this is equal to 4. So my solution set over here is when x is equal to negative 20, y is equal to 14, or when x is equal to positive 4, y is equal to positive 2. Alright, so before we go, here are some examples for you to try your hands on. I'll be leaving the answers in the description of this video, but I will not solve them. I want you to try your hands on it and leave the answers you got in the comment section below before you cross-check with the answers I have in the description of the video. Alright, so solve these nonlinear equations, simultaneous equations. So I have x squared plus y squared is equal to 10. Then x plus y is equal to 4. This is equation 1. This is equation 2. Then I have k into brackets k minus m is equal to 12 as equation 1. Then I have k into brackets k plus m is equal to 60 as equation 2. So solve these two equations and then write your answers in the comment section of this video, and I'll be sure to go through and also leave my answers in the description of this video, so you can check it out to make sure that the answers you've obtained for x and y, whether they are correct or not. So thank you so much for watching this video, and I will see you in the next one. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at linear inequalities. So without further ado, let's begin. Alright, so not all algebraic statements involve the equal to sign, and it is just as important to be able to handle algebraic inequalities as it is to be able to solve algebraic equation. Now, algebraic inequalities involve the inequality sign, that is greater than, less than, greater than or equal to, less than or equal to. Now, we also to note that the solution for an inequality is a range of possible values and not a specific value, as in the case of linear equations. Now, let's have a look at a typical example of a linear inequality. So, let's say we have 5x minus 3 is less or equal to 2x minus 15. So, this is a typical example of a linear inequality because of the inequality sign that we are having over here. So now let's try and find the possible values of x that can satisfy this expression that we have over here. Right, so solving linear inequality is just the same as solving linear equations, but there is a catch to it. Now, whenever you multiply through a linear inequality by a negative, or you divide by a negative, the sign of the inequality has to change. I'll be showing you what I mean by that. So just like the way we solve linear equations, we are going to first of all group like terms over here, because we have 5x here, we have 2x over here. So in this case, let me say this is case 1. Let's say I decide to maintain the 5x over here in the case 1 and send the 2x to the left side of the equation. So I have 5x over here minus 2x less or equal to minus 15. Then I send the negative 3 to the other side of the inequality, it becomes plus 3. So from here, 5x minus 3 minus 2x will give me 3x. I have my inequality sign. Minus 15 plus 3 will give me minus 12. So I divide both sides by 3 and by 3. So my x will be less or equal to negative 4. So this becomes my solution for this particular example. So it means my x is less or equal to negative 4. So it is negative 4 or less, but not greater than negative 4. So your answer will not be negative 3, will not be negative 2, it will not be 0, it will not be 1, but anything negative 4 or less. Right, so let's look at case 2, the case number 2. Now in this case, I would want to, send 5x to the other side of the equation inequality. So I have 5x minus 3 less or equal to 2x minus 15. So let's say I decided to move the 5x to the other side. So I'm going to have minus 3 here. Then I send the negative 15 to the other side of the inequality. It becomes plus 15. Then less or equal to 2x. Then I send the positive 5 to the other side, it becomes negative 5x. So I have over here negative 3 plus 15 will give me 12, and this is less or equal to positive 2 minus 5x will give me negative 3x. Now I divide both sides by negative 3, negative 3. So this cancels this. Now the moment I divide by negative, the sign has to change. So it means that my answer here will be 12 divided by negative 3 will give me negative 4. So I have negative 4. Then because I divided by negative, the sign will change. So it becomes greater or equal to, greater or equal to. Then I have my x over here. Okay, so I can rewrite this equation by bringing x here and then negative 4 here. So if I do that, I'm going to have x is less or equal to negative 4. So this becomes my answer. Now we need to know that over here the inequality sign is facing -4. So if you are changing the position of the variables, it should also follow like that. Because over here we are saying -4 is greater or equal to x. It's greater or equal to x. It means that over here x is less or equal to -4 is also still the same thing. So this is our answer, as we can see. So it is the same as what we have in the first method. But in the second case, because we are dividing through by negative, we need to make sure that we change the position of the sign. Okay, so you can leave your answer as this, it's still correct. But if you want to rewrite it and bring s first, make sure you have the inequality facing the number. All right, so let's have a look at other examples. So we have to solve the following inequalities. So we have 5a plus 6 is greater than 2a plus 24. Then we have 3b minus 5 is less or equal to b minus 1. Then we have 4 into bracket c minus 1 greater than 3 into bracket c minus 2. And then iv, we have d minus 3 into bracket d plus 2 greater or equal to 2 into bracket 1 plus 2d. All right, so let's go ahead and find the solution for these inequalities. So I write down my solution. I have 5a plus 6 greater than 2a plus 24. Okay, so I decide to maintain the 5a here and send the 2a to the other side. So I have here 5a minus 2a greater than, then I maintain the 24 here and I bring the 6 to the other side, it becomes minus 6. So from here 5a minus 2a will give me 3a greater than 24 minus 6 will give me 18. So I divide both sides by 3, both sides by 3. This cancels this. So a is greater than, because I did not divide through by negative, the sign still remains greater than. So 18 divided by 3 will give me 6. So it means that my answer, okay, or the values of a that satisfy this equation are all greater than 6. So from maybe 6.1, 6.2, 6.3, 6.4, or 7, 8, 9, 10, all those set of values from 7 above to infinity, they all satisfy this equation. All right, let's look at I. We have 3b minus 5 is less or equal to b minus 1. All right, so I'm going to maintain my 3b here, and I send the b to the other side, so it becomes minus b here. Then I have my negative 1 here. I send the negative 5 to the other side, it becomes positive 5. So over here I have 2b less or equal to negative 1 plus 5 will give me 4. So I divide both sides by 2 by 2. So my b is less or equal to 4 on 2 will give me 2. So this becomes my answer for the second expression. So let's look at I have here 4 into bracket c minus 1 greater than 3 into bracket c minus 2. Okay, so before we go ahead and do any rearrangement, we need to first expand the brackets. So 4 multiplied by c will give me 4c. 4 multiplied by negative 1 will give me negative 4. Greater than 3 multiplied by c will give me 3c. 3 multiplied by negative 2 will give me negative 6. Right, over here, I maintain my 4c here. I bring the 3c to the other side, it becomes minus 3c. Greater than minus 6. Then I send the negative 4 to the other side of the inequality, it becomes plus 4. So I have over here 4c minus 3c will give me c, and this is greater than negative 6 plus 4 will give me negative 2. So this becomes my solution for the third inequality. Alright, so let's go ahead and solve the last inequality that we have over here. So we have d into bracket, we have d minus 3. Okay, so let's do that. Okay, so it is d minus 3 into bracket d plus 2 greater or equal to 2 into bracket 1 plus 2d. Alright, so from here, I maintain my d. I expand this bracket. I have minus 3d here. Then minus negative 3 multiplied by 2 give me minus 6. Greater or equal to 2 multiplied by 1 will give me 2. Plus 2 multiplied by 2d will give me a 4d. So over here, I have d minus 3d will give me 2d minus 6 greater or equal to 2 plus 4d. Okay, so over here, I maintain my 2d over here. So I have 2d here. Then I send the 4 to the other side, becomes minus 4d. This is greater or equal to 2. I send the negative 6 to the other side, becomes plus 6. So I have over here negative 2d minus 4d will give me negative 6d greater or equal to 2 plus 6 will give me 8. Now I'm dividing by negative 6 to make d stand alone, negative 6. So therefore it means my sign has to change. So I have d. Now the sign will be what? Less or equal to 8 on 6 will give me negative 4 on 3. Okay, so this becomes my solution. Now if I want to write the negative 4 on 3 first, it means if I do negative 4 on 3, then I have to change the sign from less or equal to. The sign has to face this guy again before I write the d. So these or these are the same, but it's always preferred if you write your unknown quantity or your variable on the left hand side and then your answer on the right hand side. So you can leave it like this without changing it like this, but either way, these and these are all still correct. So thank you so much for watching this linear inequality video, and in the next video we'll be looking at quadratic inequalities and how to solve quadratic inequalities. So thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic inequalities. So without further ado, let's begin. Now, for you to be able to solve a quadratic inequality, you need to first of all write the quadratic inequality in the standard form, that is in the form as squared plus bs plus c. After writing it in the standard form, you need to determine the root of the inequality. Just like the way we find the root of a quadratic equation, we do the same thing for the inequality. But after finding the root of the inequality, we need to write the solution in an inequality notation. And I'll be showing you how we write the inequality notation very soon. Right, so let's have a look at an example to appreciate what we are about to do today. So we are to solve the inequality x squared minus 4x greater than negative 3. So this is the inequality that we have at hand. Now for us to solve this inequality, we first of all need to rewrite it in the standard form. So that means we have x squared minus 4x greater than negative 3. We have to move the negative 3 to the left hand side of the inequality so that this will be greater than 0. So we have x squared minus 4x plus 3 is greater than 0. Alright, so from here, we need to find the roots of this inequality. So to do that, we use the coefficient of the x squared term to multiply the constant, which is 3 over here. So 1 multiplied by 3 will give us 3. Now, which two numbers will you multiply to get 3? But if you add or subtract, you get negative 4. So if we think very well, negative 3 and negative 1 will do that for us. So negative 3, negative 1, if we multiply it, we get positive 3. But if we add, we get negative 4. So we have over here x squared minus 3x minus x plus 3 is greater than 0. So from here, I can go ahead and do my factorization. So I bring x out over here. So I have x minus 3 left for these two. Then I have between here x and positive 3 minus 1 is common. Then I have x minus 3 over here greater than 0. So I have over here x minus 1, then x minus 3 greater than 0. So I have x minus 1 greater than 0 or x minus 3 greater than 0. So therefore, this means that I have my x to be greater than positive 1 or my x to be greater than positive 3. Now, if we look at this is not our answer. If we look at this side of the equation, this side of the inequality, we are having what is on the left hand side, which is the x squared minus 4x plus 3 to be greater than 0. Now, if something is greater than 0, it means it's positive. So it means the corresponding y value that we are looking for, the y value that we are looking for is supposed to be positive. So in this case, y has to be positive. Now let's look at how we derive our answer. We have this x to be greater than 1, x to be greater than 3. So let's plot the graph. So if we plot that graph, we are going to have something that looks like this. Okay, so we have positive 1, positive 2, positive 3, 4, and I have negative 1, negative 2, negative 3, and negative 4. Now, if I look through these answers, I have 1 and 3. So 0.1 and then 3 over here. Now, for an inequality, instead of having the parabola curve, we have a straight line going through. So we are having our line passing through 1 over here, and then another line passing through 3. Okay, so this is how the graph is going to be like. Now, do we shade, are we looking for a solution that lies between outside, let's say 1 over here towards the negative, and then from 3 towards the positive, or the answer is between 1 and 3? Let's look at that. Now, because y from this side is positive, or this is greater than 0, it means that our solution should lie outside the curve, the straight line over here. I take that again. Because this guy is greater than 0, which means it is positive. So because y is positive, okay, by y I mean x squared minus 4x plus 3, because that part of the equation is positive, we are looking at the x values that will give us y to be positive. That is, we are looking at the upside over here, outside over here. Okay, those are the parts that we are looking for. Now, if y were to be negative, that is less than 0, then we'll be looking at in between 1 and 3. So we'll be shading the inside. So for this particular graph, let me use another color. So our graph will be shading the outside over here. Okay, we'll shade the outside over here. So it means our answer lies at this side of the graph, and then also at this side of this graph. Okay, so if you plot this graph in Desmos, if you plot this equation in Desmos, you are going to have a graph that looks something similar to this. Okay, but they will have here shaded much more beautifully. Anyway, that is just by the way. Now, what is the inequality notation over here? The inequality notation over here is that we have x, that is, okay, because over here from 1 downwards is less than 1, and then over here x will be greater than 3. So our inequality notation over here will be x less than 1 or x greater than 3. Okay, so x greater than 3, it means we are looking at this direction, so this side of the equation, and then s less than 1, it means we are looking at from here all the way down to the end over here, or to infinity. So it means our solution lies outside over here. So you can try that out. If you pick any number below 1, that is maybe 0, -1, -2, you realize that this side of the equation will be greater than 0. If you pick anything above 3, you realize that it will still be greater than 0. But if you pick anything in between 1 and 3, let's say 2, if you substitute 2 into this equation, you are not going to get the value to be less than 0, to be greater than 0. So it means we want answers that are outside the curve over here. So this becomes our answer. Note that this is different from this we are having over here. So we can see that this side is maintained, but this the sign changes to less than instead of greater than. So after factorizing, the roots are not your answer. You need to try and draw the graph, understand how the inequality will behave, and then you find your solution set or your inequality notation. All right, so let's go ahead and solve more examples to really appreciate what we are doing. So the next example we want to look at is s squared minus x greater than 12. Right, so because we are having a greater than sign, it means we are expecting our y to be greater than 0, which means it will be positive. So we are looking at the answer will be extremes of the 2 points that we are going to get for x. So let's look at that. So we have this, we rewrite this as s squared minus x minus 12 is greater than 0. Now we use the coefficient of s squared here to multiply negative 12. So we have negative 12. Now 4 and 3 will do this job for us. So we have s squared minus 4x plus 3x minus 12 is greater than 0. So over here I can factorize x out. So x outside bracket x minus 4. Then I have here plus 3 into bracket x minus 4 greater than 0. So I group s and this positive 3, and then I maintain one of these root s minus 4 is greater than 0. So I have over here from here s plus 3 is greater than 0, or s minus 4 is greater than 0. So from here it means I have s greater than negative 3 or s greater than positive 4. Now, like I said, after finding your roots, that is not the solution. Let's go ahead and try and plot this graph and see what we are going to get. Now, so if we draw this graph, we have, let me quickly label the answers. So I have 1 here, 2, 3, 4, let's say 5. I have negative 1, negative 2, negative 3, let's say negative 4. Now, if you look at this equation, you realize that this side of the equation is positive since it's greater than 0. So it means y is positive. Y is positive. Now, if y is positive and we have the two extremes, which are negative 3, so our line will pass through negative 3 over here, and then the other one will pass through 4. Now, because y is positive, we are looking for values of x for which the graph will be above the x-axis over here, or the values of x for which y will be positive. Okay, so for those values, it means that we are looking at the extremes. Because this is positive, the values that lies below negative 3, and then the values that lies above 4 are going to be our solution set. So if you plot this graph in Desmos, so you can download Desmos app on your phone, or you go to desmos.com and you plot this equation, you are going to have a graph that looks something like this, and this side will be shaded. So if these sides are shaded, it means y is positive. So the values from negative 3 below, and then the values from 4 above will give me a positive y value if you substitute them into this equation. So my solution set is therefore s less than negative 3 or s greater than positive 4. So this becomes my solution set. So this is my answer for this particular equation over here. Not this guy, but this guy is the solution set. And I'm explaining how we got this, because I said if you look at this side of the equal to equation, it is greater than 0. For that means y is positive. If y is positive, you shade the extremes of your graph. But if it is negative, you shade within. It means your answer will be within. So we'll have a look at an example where it will be within. All right, so let's have a look at another example. So we have 2s squared less than 9s plus 5. Okay, this is a very beautiful example. Now, let's try and solve this problem. The first thing we do is to rearrange this equation to write it in the standard form. So I have 2s squared minus 9s minus 5 is less than 0. The fact that this side of the equation is less than 0 means that our y will be what? Negative. Okay, if 0 is greater than anything, it means the thing is negative. So this equation is telling us, or this inequality is telling us that y is negative. Let's have that in mind before we continue to solve. Okay, so from here I need to factorize this. Now 2 multiplied by negative 5 will give me negative 10. Which two numbers will I multiply to get negative 10 but add to get negative 9? We don't necessarily have any two numbers that can easily give us that. So we are going to be using the quadratic formula to solve this. So my x is equal to minus b plus or minus the root of b squared minus 4ac all on 2a. So my x is equal to minus b. So my b is minus 9, which is the coefficient of x. My a is 2, the coefficient of x squared. And then my c is negative 5, which is the constant. So I have here minus b, so it will be minus into bracket minus 9 plus or minus the root of minus 9 squared minus 4. The a is 2 multiplied by negative 5, which is c, all over 2a. The a is 2 here, so let me do that. So I have my x is equal to, this becomes positive 9 plus or minus the root of, if you simplify everything we have under the bracket over here, you get 121 divided by 4. Okay, so root of 121 is 11. So I have s is equal to 9 plus or minus 11 on 4. So my x is either equal to 9 plus 11 on 4, or s will be equal to 9 minus 11 on 4. Now 9 plus 11 will give me 20 on 4, and this will give me 5. Or 9 minus 11 will give me negative 2 on 4, will give me negative 1 on 2. So I have these two values. Now remember, we are dealing with inequality, not equation. So s is not equal to, so we bring the inequality sign back. So it means s is less than 5, or s is less than half. Okay, so this is the factors or the roots. Now from here, it means we need to plot our graph or draw our graph. So let's do that. All right, so let me just use this small space over here. Okay, so I have 5 and then negative half. So let me redraw this graph well. Okay. All right, so let me shift the y-axis here. So let's say this is 1. So our half is somewhere here, negative half is somewhere here. And I have here 1, 2, 3, 4, and 5. So my line is going to pass through 5, and then it will also pass through negative half. So it's going to be like this. Now remember, when I was solving this equation over here, I established the fact that because the left hand side is less than 0, it means it is negative. Because it is negative, our solution lies in between the negative half and 5. So this is how our graph is going to be like. In between negative half and 5 will be shaded. So it means my s lies between negative half and 5. So I will have my solution for this particular example to be negative half less than s less than 5. Okay, so this becomes my solution. Because if you look at it, negative half less than x, so anything less than negative half and less than 5 will give us the solution. So if you substitute, let's say 1 into this equation, you are going to see that it's less than 0. If you substitute 2, it will be less than 0. But if you substitute, let's say negative 1 into this equation, it will be greater than 0, which means that anything that lies beyond negative half are below, and then positive 5 above will not be part of this equation. So this becomes our answer. All right, so let's have a look at one final example. So example number 4. So we have 2x squared plus x minus 15 is less or equal to 0. Okay, so let's go ahead and factorize this, since the equation is already in the standard form for us. So we have 2x squared over here. Now 2 multiplied by 15 will give me negative 30. That negative 30, which two numbers will I multiply to get negative 30 but add to get 1? So I will have 6 and 5. So positive 6, negative 5 will do that. So I have 2x squared plus 6x minus 5x minus 15 is less or equal to 0. Now, if something is less or equal to 0, it means that we are expecting our y to be negative. Okay, let's note that. Since this side of the equation is not greater or equal to 0, it means our y is negative. So it means we will be shading in between the two values of x that we'll get for this quadratic equation. So that is something you should note down. So always try to see whether it will be y will be negative or positive. That will tell you where to shade. Okay, so let's continue. So we have 2x common here. So I have 2x into bracket, x plus 3 here. Then over here I have minus 5 common, then x plus 3. This is less or equal to 0. So I have here 2x minus 5, and then x plus 3 is less or equal to 0. So from here I have 2x minus 5 less or equal to 0, or x plus 3 less or equal to 0. So 2x less or equal to, I send the 5 to the other side, it becomes positive 5. Divide both sides by 2, my x is now less or equal to 5 on 2, or this is 2.5. Or over here I have x less or equal to negative 3. Okay, so let's go ahead and draw our graph to see where our answer will be. Okay, so I have here negative 1, negative 2, negative 3, negative 4. I have here 1, 2, 3, 4. Okay, so I have 2.5, positive 2.5, so something around here, somewhere here. Then I have negative 3 over here. So my graph will pass through negative 3 all the way down, and then 2.5 all the way here. Now, because I established over here that y is negative, because if you look at this equation, we are saying that it's less or equal to 0. So it means y should be negative. That implies that we have to shade inside of these two lines. So this is where our solution lies. It lies in between over here. So it means my x is in between negative 3 and 2.5. So my solution over here will be negative 3 less or equal to x less or equal to 5 on 2. So this is how we solve quadratic inequalities. First of all, we rearrange the equation in the standard form. We try to find the roots. Now with that roots, we draw a graph, okay, plot the jot where the 2 points that we have for as the factors or as the zeros of the equation. We tick them and then draw a straight line through them. Now we have to consider the equation. If the equation is greater than 0, it means y is positive. So we paint the outside of the graph, outside the two values that you get. But if it is less than 0, something that is less than 0 is negative. So you paint in between the two lines that you've drawn, and then you write the solution set appropriately as required of you. So thank you so much for watching, and I will see you in the next video. Bye bye.